So as you can see, we are going to build this morning. This morning, we're focusing on our coupler assembly, motor mount, propulsion, and our nose cone and our rail buttons and vent holes. This afternoon, after lunch, we'll be working on our inner and outer fins. And then after our afternoon break, we will finish up with our aft centering ring, you know, that one that didn't have the holes for some of you. We'll get that put in along with our recovery system. And then we'll go over at the end of the day, what we'll be doing or what's needed for our certification launches. So with that being said, one of the things that we're going to need to do is verify that everybody completed all of the steps last night, because we ended up being a little bit late getting off. We did not confirm that everybody had gone through steps 3 through 5. So with that being said, what we'd like you to do, if you have finished step number 3, or let me rephrase that. If you have not finished step 3, can you please put a U, we'll do a U in the chat for us. So add fillet on aft side of forward centering ring. Do you have the?
We're not using fillet, correct?
We are putting a fillet on the aft side of the centering ring. Mark, is that in your window? Sorry, I don't have the right screen view yet.
Yeah, I'm showing the middle. Yeah, I'm showing the back fillet.
Right.
I'm getting a blank screen, Mark.
Yeah, 1 second. All right, there we go.
So the forward side has a fillet and the back side has a fillet.
So we have to put a fillet on the back side of your forward motor mount ring, centering ring.
So just the forward one,
Yep.
not the mid one. The mid one stays clean.
Okay, so it looks like Anthony needs to still do it. D'Angelo, Tyler, Scott.
Yeah.
Yep. So what you'll need to do is take out your epoxy.
Don't forget your gloves.
Yep. All right, then.
There might be some people that are having connection problems because people are dropping off and then signing back in, just to let everyone know.
And if you haven't done it already, also add some epoxy to the threads of the eye bolt in the back by the nut and your T-nuts. Just the flange of the T-nut. Do not get it in the threads if you haven't done that already.
Or in the hole of the T-nut, right?
So that's step 4.
Yep.
So do the fillet first, and then with your remaining epoxy, I still need to do step 4 myself. So I will demo step 4.
Confused as to what's the difference between adding epoxy and a fillet.
A fillet is a portion of epoxy that you spread on the part between the airframe or the motor mount and the motor mount ring, just like it shows in this picture you're looking at right now. See where the epoxy is? And that yellow spot right there, that's a fillet. So it's a bond between two materials, the fin and the airframe.
Usually at a right angle
Right.
is a
In this
fillet.
ca- Yeah, in this case, it's a fillet between your motor mount centering ring to your motor tube.
So when we dab epoxy on here, it's not a fillet. It's not called a fillet. When we put it on here, it's just, well, applying epoxy.
You're locking the threads.
Yeah.
Yeah.
When we put it on here, however, it's called a fillet because now it's at 90, it's joining two pieces at 90 degrees.
It might be easier to think of a fillet as more of a cosmetic joint. It's structural, but it looks pretty, right? And if we're just dabbing the threads to keep it from becoming unthreaded, it's just kind of, doesn't have to be as pretty. It's just locking the bolts and the thread together.
Mark, Anthony is asking if you can show how to do step 3 again, please.
So it's hard because I don't have the epoxy. I don't want to, because I've already applied it. But what I'm going to do is mix my pot of epoxy, right? So you mix the epoxy with your stick, and then you'll just apply it. Instead of applying it to the tube and then moving the ring, we're just going to apply it in the space between the ring and the tube. So you're just going to apply just goops of it, just goop it all on there. And then at the last, once you have enough gooped on there, you'll make one smooth final pass. You'll try and get that smoothed out.
And remember, your epoxy is a 1-to-1 mixture.
So mix a good pot, get a lot of epoxy on there, and just kind of goop it on all the way around.
Kind of think of it as squeegeeing the epoxy as you move the centering ring into position.
And I just want to check on Tyson. It looks like you're putting epoxy in your centering rings. So do you not have your centering rings on the tube yet?
He's doing T-nuts.
Okay, gotcha. Thank you.
And then while you're also doing the front centering, you could dab the back side of the T-nut as well with the epoxy.
Just the flange of the T-nut. Do not get it in the threads in the hole.
Sorry, the eye bolt. You can dab the eye bolt on the forward while you're doing the ring as well.
Okay.
Could you repeat that for Andrea? We lost her for a little bit, what we're doing.
The whole thing.
Well, yeah, just really quickly. I don't know what she heard.
So we're doing step 3 of the slide. We're adding a fillet on the aft side of the forward center ring. So I'm displaying it right here. This is the forward center ring, right, F, and the aft side, which we didn't do yesterday, which I believe the majority of us didn't do. So I have my epoxy already on. You're just going to goop it from the pot, apply it all on, and then make one final smooth pass. Make it nice and clean.
And she gave us a thumbs up, so we're good.
And then while you're there, you can also dab the threads of the eye bolt to prevent that eye bolt from ever coming loose.
And don't forget to position your material so gravity will stay with the epoxy on the material so it doesn't slide off.
So while it's drying, keep an eye on it, that the epoxy is not all running to one side of it. You might want to rotate it or position it standing up to let it dry.
Nikki, we lost you for a little bit too. Are you in step with us? Nikki?
Looks like she's still trying to connect.
I had a big log in with my phone. Oh, Nikki had to log in with her phone.
Okay. So she's caught up, but her Zoom keeps quitting, so she's on her phone right now.
Wasn't fillet also referencing where you add something to the epoxy? So that's why I was confused.
No, not so much. I think earlier in the epoxy slide yesterday, right, we talked about filler that you
Filler,
could use.
okay.
We're not using that on our build today, but yeah, the filler would make it so it doesn't run. So you wouldn't have to worry so much about it moving while it's drying.
Yeah, so then now that I have epoxy on kind of both sides of this aft ring, which way do I hold it? If I hold it one way, the one part's gonna drain, or
Well, it
You
should be
mean-
dry on the top from yesterday, right? This side should be dry. It only takes about an hour to cure. It's about 5 to 10 minutes to set and about an hour to fully cure.
okay. Yeah, I think it would help too if I had like white based kind of epoxy that you have, then I can kind of see what's going on. Having this clear stuff, it's kind of hard to.
I'll admit I cheated. I added a little filler to mine too. I didn't have to worry about the running issues. We can move on to other things to show you guys.
And just to clarify, it's the forward centering ring with the eye
forward,
bolt in
yeah.
it.
Yeah, forward.
Just want to make sure you're not doing your aft one.
Just the forward one. So don't do
Yeah.
the mid one. So the back side or the aft side of the mid centering ring should be clean, should be clear. There shouldn't be any epoxy on the aft side of the mid ring.
Yes.
And so one of the things that we're going to do a little bit different today, because it will help our team, is for when you are done with a step and you have it completed and you put your R in the chat box, we'd love for you to put your piece up into the screen so that we can see it, and keep it there, as Frank is doing, until somebody says, Aaron, that looks good. No, that doesn't. That's missing the 1/4 inch on top. What are we going to do now? But until somebody signs off on you, keep it up there so that we can get a good look at it. Because that was one of the difficulties we had last night, was when you put it up and then you take it down right away and we didn't have enough time to look at it. So looks like D'Angelo, you're ready to look at it.
Sounds good, but why don't you hold it up vertically though? So gravity, there you go.
Good.
Actually, mine was, yep, there you go, upside down, because that's the side the epoxy's wet on and curing. Looks good, bud.
Okay, looks like Willie is needing a review.
Scott, look like you look good. Anthony, perfect, Anthony, right spot, looking good.
Bryson, you look good.
Aaron's got it.
How you doing, Marlon?
And Maria said she's having some difficulties with her videos or her camera, so it might be difficult to show hers. Tyson, I have to ask, what time is it for you? Is it like 6 a.m.?
Looking good, James.
Yep, it is.
We're so sorry, but thank you for playing nice with us.
All right, Tyler. Looks good, right, guys?
Yeah. Do I need more epoxy for that?
Taylor?
Tyler.
looking.
Tyler, is it going up onto the motor mount? It looks like it's just on the ring. I can't tell. Can you guys tell?
Tyler, can you show a little closer to the camera? It doesn't look like you have a very good fillet on there.
Yeah, should I add more?
Yeah, add a little more and then kind of put it in crease it in the seam between the motor mount and the centering ring.
As I like to say, like, consider you have these two, like this 90-degree angle, and you want to put that skate ramp right right in between it, so that you're able to do whatever it is you do in skating. I don't know, but anyway,
For you skaters out there, we're making a little skate ramp for all the little mini people that want to skate on our motor mount.
Hey, don't make fun. But
Is this a launch ramp or a half pipe?
It's called a half pipe.
Quarter pipe, actually.
It's a half. Yeah, it's not a lot. It's not.
Hi,
Um,
girl.
just
Fit
going
in.
back to Tyler, sorry, it looked like maybe your mixture was runny because it looked like it was really, really thin and loose. So just make sure you have a good 1-to-1 ratio between the two mixtures of epoxy, okay? So it thickens up.
Okay.
And also let it mix for a while. So if you mix it for a good minute and you even wait for a minute or two, it'll start to thicken up. Don't wait too long. The pot's only good for about 5 minutes. If it gets really sticky, just set it aside, make a new one.
'Cause 5 minutes goes
Taylor.
by fast.
There you go, Taylor. I see you're holding up your bulkhead there. You got epoxy on that backside? Perfect. Remind me, you didn't have epoxy yesterday, right?
I did.
Okay. Anthony's looking for a check too, I think.
Taylor, did you find that 1/4 inch nut?
No, I'm gonna look again.
That's all right. Just a test.
Nikki, I see your so you got the motor mount tube up and it looks like the eye bolt is up forward. Did you just put epoxy on the top side or the bottom and the top?
I think the bottom.
You can flip it upside down and it'll hold the epoxy in place a little better versus being upside down.
Yep, put the eye bolt facing down so it doesn't drip. Andrea, how you doing? I see your picture. Let me see the backside of that forward ring, the backside. Oh, yeah, you need to put some epoxy right in there. Yep. On the aft end of that forward centering ring, you need to put some epoxy, make a fillet around there between the motor tube and the forward aft motor ring. Nikki, how you doing?
I think I got it. Just leave it upside
Yep.
down, yeah.
Leave it
Got it?
upside down.
Very good.
You cut out for a little while there, so I'm not sure if you could hear me or not.
Yeah, my phone's logged in, but the camera situation on this one's kind of hard, so I'm just logged into both.
That's okay. I figured you're doing a really good job of holding still or something was wrong with the camera, one of the two.
Yeah.
So if we think that we're at a good spot, do we want to move on to the next section?
Are we good with step 4? Has everyone also epoxied the backside of their eye bolts?
You've completed 3 and 4. Please put an R in the chat if you have not done so already.
And epoxy on your T-nuts.
All right, I think we can, looks like we just might have one person still working. But I think we can move on to the next step.
Is that the coupler?
It is the coupler assembly, correct? So the
Okay.
step number 1.
Okay, everybody dry fit their ball plate inside their coupler and make sure it fits. I think we did this yesterday. Mark's got the example. Let me get back to Mark here. There you go. And make sure you can fit your bulk plate at least 3/16 to a 1/4 inch inside the coupler. If you have a hard time fitting it, you can sand it a little bit, but it should be a snug fit. Okay, once you pull that out, mix some epoxy up because we're going to apply some epoxy to the internal
part of the coupler, what Mark is showing with his finger. And with that little extra epoxy that you apply on the inner part of the coupler, you're going to dab it on the back side of the bulk plate on the threaded nut eye bolt.
If you haven't done so already.
Right. And once you got a bead of epoxy inside the coupler within 3/16 or 1/4 inch, insert your bulk plate into the coupler and hold it there till it doesn't move anymore. You may have to squeeze it around, squeeze your coupler a little bit to keep the bulk plate in place, because it might be a little loose and sloppy, especially when you add epoxy. It kind of lubricates it and it'll be a little slippery. So just keep it in that place like that for about probably a good 2.5, 3 minutes, and it'll stiffen up and stay there. And once you have that set, you can lay the coupler on its side. Don't lay it down on the open side, lay it on its side, otherwise it may shift. And lay it off to the side. And once that epoxy has kind of set up on your bulk plate, I suppose it'd be time to put a nice fillet, as it shows in number 5. Apply a fillet on the forward side of the bulk plate. That's the side that the eye bolt sticks up, and put it between the bulk plate and the coupler on the inside. See what Mark's doing there? He's got
Just want to put the epoxy about 1/2 to 1/4 inch in, and then slide your ring inside of that.
Right. You may have to hold it there for a minute or two so the epoxy gets set. And if you have extra epoxy, start making a fillet around that bond between the bulk plate and the internal coupler. And if you have to make some more epoxy, go ahead and mix a little bit more. Don't forget 1-to-1 ratio. If your epoxy is still tacky after a good half hour, 30 minutes, you haven't mixed it right. It's still kind of like super gummy. Or runny. And as soon as you've completed at least through step 5 or 4 at least, let's see an R in the box, please.
I'm guessing most people are still on maybe mixing their epoxy or just about putting it in, so.
Don't forget your gloves.
Hard to get off your fingers if it dries on your fingers.
Yeah, and when you're mixing epoxy too, it's a good thing to kind of like maybe tear open one of your alcohol wipes. Don't expose it, just kind of tear the pack open so you can quick grab it and wipe if you need to.
Make sure you keep the outside of your coupler clean, nothing off your gloves or drips.
That's right. If you get any epoxy inside or outside the coupler, you will not be able to get it on your airframe. So if you see some epoxy on there, take your alcohol wipe and wipe the epoxy off the external part of the coupler. Thanks, Bob.
Looks good, Andrea.
So I'm just also rotating. I don't know if you guys see me. I'm rotating the coupler. I'm waiting for the bulkhead to set, waiting for the epoxy to set before I continue onto the fillet. Just make sure it doesn't move. It's going to slide, so keep an eye on the bulkhead.
If anyone could spare an eye, Andrea has hers done. She's holding it up and she's rotating it around. It looks really nice, looks really clean. Doesn't look like there's much, if any, epoxy on the outside.
I have a question.
Yep.
My piece that fits into the tube is like loose, like to where you could shake it. Should I just apply more epoxy to like fill that little gap?
Let me see. Are you putting it in the coupler?
Yeah.
Let me see. I can't. Oh, it's staying there. Just put your hand around it to keep it in that spot, and just kind of squeeze it a little bit until it sets up, like in about 2 or 3 minutes.
You can squeeze it to apply some pressure, help it out a little bit.
Right.
Prevent it from moving.
Okay.
But just remember, because it's wet, the epoxy is going to slide. It's going to roll down to that, so that's why you kind of want to rotate it around. Make sure the epoxy doesn't run to one side.
Yeah, kind of look at the back side of it and the front of it, make sure it's all lined up straight. Straighten it out if it needs straightening out, and apply a little pressure and squeeze the coupler a little bit and just keep it in place.
Hey, Christine, would you mind if I send you to a room with Cody to chat about epoxy and maybe attending a different session?
Sorry, I didn't quite, you need me to go to a room with Cody about epoxy?
Yeah, Cody doesn't have epoxy, so if you want to maybe talk to about attending a different session or
About what? I'm sorry, I'm having a hard time hearing you, Danielle.
maybe attending the week-long session or just figuring out a different schedule since he doesn't have the stuff to complete today.
Okay, actually, why don't we send Connie, because she'll work with him to get them all situated for the week. Is that okay, Connie? Perfect.
Andrea, I noticed you put epoxy on the outside of the nut. Did you put some on the inside too? On the nut? Okay, thank you.
All right, Cody and Connie, if you just want to accept that invitation, thank you.
Should we move on to the outer fillet now?
Yes.
Okay, observe what Mark is doing there. He's going to be mixing some more epoxy if he needs it, 1:1 ratio, and he's going to put apply a fillet between the bulk plate and the coupler, where you have your 1/4 inch or 3/16 inch bulk plate attached to your coupler. It's going to be on the outside. Apply the fillet on the inside of the coupler. Do not try and get any epoxy on the outside. Just on the inside between the bulk plate and the internal part of the coupler. Yep.
Yeah, try not to get it on this side. You want it all on the inside.
Right. And if you do get some on the outside, wipe it right away with one of your wipes. I was looking up the word fillet. And of course, fillet, they refer to as a fillet. And if you know what a piece of meat, a fillet is cut like a fillet, that's exactly what you're doing with that epoxy. You're laying like a long bead of epoxy between two materials.
You also have a gap fillet with something.
Yep.
So still mixing, just letting it harden up a bit before I apply it. I don't want it to be too runny. Oh, it's beautiful. Get it in there now.
Aaron, how's it going? I see you holding it up. Looks good. Got it all around?
D'Angelo's got it.
Hey, Nikki, do you have it done? I can't see if it's just shadow or if you're done on your coupler.
Done. It's dark out here, sorry.
That's okay. I could see the dark ring. I couldn't tell if it was the shadow from the overhead light or not. Willie's got it. Willie was using his craft stick. Looked really good.
Grayson, how you doing?
Looks like Scott's got it. D'Angelo, how's yours
Just
look
had to
like?
mix it a little bit more epoxy.
Okay.
I can't see because of the light if you got the epoxy on there. It's on? All right.
We believe you. Marlon, how you doing? All right.
Looks good, bud. Thanks, D'Angelo.
Does mine pass inspection, Kevin?
Sure does.
I got a little on the outside here. I'm gonna have to wipe that up. Look at making mistakes already.
Hey, I did the same thing. It's okay.
Andrew, you're doing real good.
James, looks like you got it. And Maria was with you, correct? All right.
Because if
So
you
yeah, if you get any on the outside, you can use your wipe to wipe it off if it's still wet. Make sure you don't get any epoxy on the outside of that.
got it, Taylor.
Anthony's
job.
got it. Good job, Anthony. Right now, Andrea's using her craft stick to apply the epoxy.
Yeah, it's the perfect workshop view for us to see everything. Thank you.
Looks good.
It looks like most people are kind of wrapping up this step. So just finish your epoxy and start listening into what we'll be moving into.
Were we supposed to do the coupler?
The next slide is, yeah, or did we move that? We might have moved it, Frank.
Okay, because I see it in the handbook, it's the next one, but in the slide, okay, never mind.
Yeah, we were giving it time to, we're giving the time
Yeah.
for
Yeah,
the paint to dry.
Yeah, you're right.
So keep
Everybody,
an eye on,
when you're done with your coupler, lay that to the side and so it doesn't roll off the table. Of course, you can lay it down so the epoxy rests between the bulk plate and the internal part of the coupler, so it doesn't run. So lay it down off to the side, up and eye bolt up. Okay, I'd like to know, does everybody have at least 2 quick links? And Mark, show them what a quick link looks like. I don't have one open here.
I've got
Quick link.
two different color, two
Yep.
different material quick links.
You should have 2. If you don't have 2, it's okay. We're going to attach the shock cord to the forward centering ring that has the eye bolt.
Taylor, do you have a question?
I only have one.
You only have one? Okay. I want everybody not to use a quick link on the forward motor retention system. We're going to do a little slip knot. We're going to take that loop on your cord, on your safety cord. You either have a blue one or a red one, recovery cord. And see this picture that's that's showing here? Take the sewn loop, one end, and put it through the eye bolt like it's shown in example picture number 1. I'll give you 30 seconds here to unwrap your recovery cord.
I'm gonna demo I'll demo the knot, but I'm gonna use the quick link.
Okay.
I have 2 different sizes of quick links.
That's no big deal, no problem. You're okay. Do not use the quick link though on this attachment. Mark is, but don't use it so we can make the parachute and the later on the parachute and the parachute protector a lot easier to install.
Ready to walk through this or just tie it?
Yep, just loop it. Put one end of the loop through the eye and then go to the other end of the recovery strap and put it through that loop and slide it through, just as the picture shows. As picture 1 shows going through the eye bolt, and picture 2 shows the other end of the recovery strap going through the sewn loop. And make it as close and as tight as you can to the eye bolt, as shown in picture number 3.
Looks like Aaron's got it. Looks like Willie's getting it tightened up. Nikki's got it. Tyler's taking the slack out of his. D'Angelo looks like he's got his done.
All right, Taylor, good job.
Scott's got it.
Tyler's got it.
Looks like Andrea is pulling the slack out of hers.
Very good.
Good job,
Who
Tyler.
won, who won the race?
I think Aaron did.
Okay.
All right. So let me go.
Grayson, how you doing?
Tyson.
Great. Got her done, Nikki? All right. Okay, what you're gonna do next, you're gonna recoil your shock cord 8 to 10 inches in around your hand. I think is there a picture of that? I'm not sure there was a picture of that. Yep.
Yeah, figure
Yeah, I got it.
1311.
Yep. Yeah, make a small coil around your hand, 8 to 10 inches round, because the object of this is to secure this recovery cord inside the motor mount tube. Once you coil it up, take some masking tape. You guys probably haven't busted open your masking tape. We'll give you a few minutes to cut the paper around it and try and find the end of it so you can peel off about 3 or 4 inch piece of masking tape and wrap it in the center of that coil, because we're going to end up stuffing that inside the tube so it doesn't get full of epoxy when we install the motor mount inside the airframe. Excuse me.
So not too much tape. It doesn't need to be super secure, just enough to keep the bundle from coming undone.
Yeah, if you wrap it 3 or 4 times, it's gonna be hard to, because you got to break it loose later on when we're all done. And once you get your coil and one little round single layer of tape in the center of your recovery strap in your bundle, I want you to stuff it into the motor tube from the same side where the high volt is. And make sure that recovery strap is clear of all obstacles when you want to put it inside the airframe.
Willie, what do you mean by regular tape? You mean like Scotch tape?
Scotch tape?
Sure, Scotch tape will work, but everybody should have masking tape, right?
Yeah.
Scotch tape? I don't think I have masking tape.
Oh, probably because of the people that had to use, yeah, I get it.
You could probably do it without using tape if you're kind of tidy and get it all packed in nice. Tyler's got it.
Andrea looks like she has it.
And the important thing too, I don't think was mentioned, is you want it all, you don't want any of the end exposed. You want it all inside push it as far as you can, push it as far down as far as you can.
Yep. You got it, Nikki, you're good.
Taylor looks good.
So we don't have to be concerned about the loop on the other end as we stuff this in?
Yeah.
All we're really doing is protecting the shock cord so it doesn't get epoxy on it as we put everything together. Just put it in a neat, tidy place.
Aaron, yours looks good.
Yep, yours looks good, Aaron. Marlon, how you doing?
Looks
good.
Excellent, excellent.
Scott's got it.
So if you're done, also make sure your other components haven't moved while they're drying. So make sure to check on your bulk plate still.
And since a lot of you are pretty close to done, for those of you who are done, maybe we can explain step 5.
Okay. Once your recovery strap is out of the way and clear, I want you to take your airframe, the one that has the fin slots in it, and install a motor mount into the aft end of the airframe. You may have to install it maybe at a 45-degree angle to push it in. Don't put it in straight flat like a pancake, kind of put it in a 45-degree angle and then push it in. And don't fight it. If it's rough to get in, you'll have to sand the outside of the motor mount ring, because if you try and force it, you'll get those burrs on the end of the airframe and the internal. It'll be even a big struggle for you. I want everybody to pre-fit that, make sure that fits in there. And once you get the mid motor mount ring in there, push it up as far as the top fin slot. Just make sure it's all clear that you can get it up that far. You should just clear the top of that fin slot with that mid motor mount ring. Bryson, how you doing? There you go. You gotta take your fins out, yeah. Won't be able to.
You could try, but you're not getting anywhere.
No. So don't try and force it all the time, because you'll get burrs on the end of your airframe and the cardboard will start peeling back. So you'll have to actually sand that cardboard if you've got a burr on the end of that. If you have problems, just keep sanding the external part of the motor mount ring, the outside, to make it fit. It should slide in and out with a little resistance inside the airframe.
Willie, did you sand your airframe? If it's catching, it's probably because there's a lip on the airframe. It's easier to take the paper off the airframe to make it fit than it is to take the wood off.
Yeah, Angela, how you doing there? Are you stuck? Or are you good?
I got the first one in, but the second one got stuck.
Okay, so that means that the second one needs to be sanded, or you just put a burr on the airframe from putting in the first one or the second one.
Good job, Taylor. Looks good.
You may have to twist it
Aaron
to
looks
get
good.
it in.
Aaron's looks good. Anthony, are you caught up? Is it catching? Does it go all the way in?
Oh yeah, he's got it.
Perfect. All right.
Test.
You may have to spin it in there, Angela. You may have to turn it to twist it, put it in, perhaps.
Good, Willie.
There you go. You get the hang of it. Why don't you make sure that goes in again there, D'Angelo. Pull it out and see if you can go back in again, because I don't want you to get epoxy in there and then you get stuck again.
Hard to see the,
Pull it back out again, D'Angelo, all the way. There, now try putting it in again real easily so we don't have any problems after we put it in on a 45-degree angle. There you go.
Did we
Andrea.
have to use the quick links?
Not yet.
Not yet.
We're gonna,
Okay.
yeah, we're gonna save them for later.
My middle ring is a little bit too big. I'm or taking some sanding.
Okay. Twist it in there, D'Angelo. There you go. Could be a little tight. And like Mark says, if you can't sand that much cardboard on the internal airframe, you can peel a little bit of cardboard off. Not a ton, just a little small layer if you have to. But of course, every time you peel off a layer, you're making another burr further down into the tube also.
yeah, Scott, so try and sand the airframe first, make it fit, and then if not, then sand the center ring.
Tyler, you hit the wrong way. That's your eye bolt, right? There you go. Flip it around, put it in the other way, Tyler.
Okay.
So eye bolt goes in first.
Yep.
Eye bolt ring goes in first, forward ring.
Yep, you got to watch Mark's example there. And don't we have a? I'm gonna have a picture. You got Mark's picture.
Andrea, how you doing?
I have to sand the rings.
Okay.
We do have a picture, like Mark is showing here.
There you
So since everyone's done with 1 through 4, step 5 is the same as 6. So right now we're just making sure we have the good fit.
Okay.
Epoxy inside parameter. Oh, oops.
I should say perimeter, shouldn't it?
Grayson, how you doing? Are you having a hard time trying to get inside the tube, or are you managing there?
Oh, this mid ring is a bit
Can you twist it in?
I mean,
Yeah, it'll be snug. It'll be, you gotta persuade it.
Tyler's cleaning house.
Look at Tyler over there. Did we issue that? Did we ship him that? How come I didn't get one of those?
Yeah, how come you guys ain't have one?
Yeah, there's a lot of dust from sanding.
Is that a handheld Dyson?
Yes.
Oh, can I, my wife would like one, please.
Okay.
All right, Grayson, you got it in there. Good. Was it kind of real hard to get in?
somewhat.
Okay. Can you pull it back out and put it back in again?
Yeah, you need to do it multiple times, Tyson. So
yeah,
this is just a dry fit step. So one thing to be sure, Tyson, is you probably have burrs on the edge of your, if you look.
Airframe. Yeah, Willie, you look good. You got a good move there.
Yeah.
Tyson, you probably have burrs on just on the edge of this airframe here. So sand down, try and sand down the edge of the airframe as much as you can. You're trying to taper it, right? So that that ring can sit in the taper and slide in nice.
Okay, good.
I see D'Angelo's doing the same thing, cleaning up those burrs on the edge of that airframe.
But he doesn't have a vacuum cleaner to clean up the little shavings.
Yeah.
All right, I think if
Real
we
good,
want to
real good,
start,
Marlon. Real good, Marlon.
I think everyone has the idea for getting your proper fit. Just for time's sake, we're going to start explaining step 7. Okay, so for everyone who's ready to move on to step 7, you can start as Mark and Frank are showing. If you're not ready, just listen and try and keep up, okay?
Here we go. Okay, step number 7. Let's mix some epoxy.
Let's
You
get
have to
the
put
stick ready first.
Yeah, get your stick ready. You have your 12-inch stick.
I'm using my ruler because I don't have a dowel.
If you don't have the 12-inch stick, tape your craft stick to the end of the ruler if you have to. There you go. I see Grayson's got a stick. And tape a craft stick onto the end of that, because the round dowel does not pick up epoxy very well. It'll fall off pretty quick. So tape your craft stick to the end of the dowel.
I had to tape 2 to reach because I got the longer motor mount from last year's model.
Yeah. So, yeah.
So 12 inches is not going to go all the way, Tyler. So you want to make sure that you are putting a craft stick onto your ruler or onto the dowel to make a longer stick.
Yeah, taping that together like that, exactly.
Because you're gonna have to apply glue up almost to
So
the
either
right to the
craft
forward
stick,
motor mount ring. Yep.
craft stick to dowel or craft stick to ruler. You should all have a dowel. I should be the only one using the ruler. Yeah, that's the dowel, Chison. So tape a craft stick to it. I can't see it. Yeah, okay,
Yeah.
you're good.
And just make sure, look at figure 1313 that's on the slide right now, if you can see that, or in your handbook. That's how long you want your stick to be able to reach, is up to the forward centering ring inside of the airframe.
Yeah, so for mine, for example, I need to reach all the way in to apply epoxy here inside the airframe.
And the best way to, once you get your stick set up to grab some epoxy, it's best to lay your airframe down on the table. Okay.
Andrea, the other end goes in first.
I had one computer go down. You gotta restart this one. Sorry.
So Frank, can we verbally go through step 7, 8, and 9? Then what I'd like to do is have Aaron do his overview of the propulsion or coupler and sustainer while everybody's working. And then if you have questions, we'll be monitoring the chat to see what we can do to help. So our team, make sure that we're going back and forth, and if we need to break anybody out, we can. Okay.
Got it. Can you hear me okay?
Yes. We can.
Okay. Mark, you went dark on me? I don't know which one you got dark.
You're looking at the other one.
Yeah,
okay.
You're looking at the wrong one. The Mark A is the audio.
All right. Because my computer just went down. I'm using my iPad now.
So we'll walk through 7, 8, and 9.
Yep. Does everybody have their stick ready to go?
Okay, Chison, yeah.
Yeah, let's walk through it, talk through it, and then we'll monitor via chat that everybody's doing what we
Right. Once you have your craft stick taped to your dowel, mix some epoxy up, and what we're going to be doing is adding epoxy to the end of your craft stick, and we're going to go at least 12 inches inside your airframe and put some epoxy around the internal part of the airframe where your forward motor mount ring is going to be mounted once you slide your motor mount in. As you can see in the diagram there on figure 1313. See how far up that forward motor mount ring is, the one that has the eye bolt with your recovery strap tied to. That's about where the glue has to go, or the epoxy inside the airframe. So be careful not to get any more glue than you have to inside the airframe, except for that one general area.
So try and get as much as you can inside there. It's going to take you multiple scoops to get, you know, and rotate the airframe around. That's why Frank says lay it flat on the table. It's easier to just scoop, put your stick, drop, rotate, scoop, put your stick, drop, rotate, and just keep putting it all the way around the airframe.
Right, and the object to this is get your epoxy as close as you can in one hand and your stick in the other to the object you want to insert the epoxy inside the airframe. You're not dripping epoxy, you know, prematurely on the table and the airframe inside before you get to your destination.
Yeah, you don't want to, you want to make sure that you don't get epoxy on those slots, because that's where your fins are going to go into. And you want those holes to be completely free.
So that would be step 7. And then
Correct.
step 8, Frank.
Once you've completed the epoxy application inside the airframe, slide the motor mount tube into position. And to get the correct position, make sure that the mid-centering ring is just clear of the top fin slot.
It's hard to see in my lighting because the slot's so narrow, but you'll want to push the centering, that mid-centering ring, just so it clears the fin slot.
In figure 1314, you can almost see where the red arrow is, just to the right of it. We see the ring is not impeding the slot area, so it's just beyond that, and that's what you want to make sure of.
Andrea, I can see you wrestling with that second ring. If you give it a little bit of wiggle as you put it in, is it still tight?
Yeah, it's
And then,
pretty much. Seems fine.
If you pull it out just a little bit, is it starting to mushroom a little bit around the back of the airframe tube?
Yeah, she was forcing it in there pretty tight. I think she's starting to bend it over.
So that's the step 7, 8, 9. If you think you're comfortable and understand all the steps, then you can start to mix your epoxy.
And Andrea, since you got sandpaper in hand, maybe go around the back end of that airframe tube a little bit more. Yeah, right there.
Yeah, you can sand it pretty hard to get that off of there.
All right, I'm going in.
Okay, with that being said, Erin, do you want to go ahead and start your overview for the section?
Aaron, you mean for your demo on the message?
Oh yeah, I want
right now.
How far the inner centering or the aft, mid, and forward centering rings are, because they don't match what I have in my rock sim.
Oh, mine's going to be different too because I got the older version. But, 5 1/4.
I guess we'll just have to guess.
And just for a reminder, while we have the different screen up, in your build part of your workbook, that's what I was trying to, do we know what page that was on?
The one that we just left off with is 61.
Yes.
So
So page 61, why don't you, if you need to, have that open in front of you. So if you need to refer back to it, you know exactly what you need to do.
Aaron, my tube.
Yeah, go ahead.
Okay. Go ahead, Aaron.
Aaron, I'm going to give you these numbers because I need to get on with the other step, but my tube is 17. The distance between the front two is 11. And then that mid to aft is 5 1/4.
Okay, thanks.
I'm gonna keep Mark's screen spotlighted since he's still doing these steps. So if you guys get lost, remember to go to handbook page 61 and then also check in on Mark's screen and watch that, okay? Aaron, it's all yours.
Okay, sounds good. So the motors we'll be using, you guys are building the place that will put the motors, but you guys have probably seen those little Estes black powder ones. Those are ones you can buy at Hobby Lobby, but HPR on this slide, that's high power rocketry. That's what requires a certification to build, and that's what the point of this workshop is. And that's motors with over 160 Newton seconds of impulse. And I know that doesn't mean much, but I'll try to compare it. Have you guys heard of the Mercury Redstone rocket from the early 60s? It's like a pretty small rocket, but it goes to space, and it took the like one astronaut to it. If we were to expand that table 6.1, like H motor with 160 Newton seconds, and each letter doubles, like an I is double that impulse, and a J is double the I impulse. So if you're to keep doubling that up to real industry motors, Mercury Redstone would be a Z motor. It has about 49 million seconds. A Falcon 9 would be you'd have to redo the alphabet, an AD motor, and that's about 671 billion Newton seconds. And the SLS and Saturn V are the AG, that'd be about 5 times 10 to the 9 Newton seconds. And that just is a way to describe the impulse. There's also the thrust, impulse, and specific impulse. But that table there in 6.1 is the ones within the high power rocketry realm. And if you ever see at any of your local launches, someone who's certified to level 3 launch on one of those M, N, or O motors, those are huge. Like they have to walk far back in the range to get it far enough away to be safe. And those things are super loud. But as I said before, they can't just be purchased at Hobby Lobby, and that's what this workshop for. And for your competition, you'll likely be using a level 2 motor, like an I or a K. And that's why we have you guys find local rocketry mentors, because even with this workshop, you'll only be certified to level 1, and by level 2 for your competition, you need someone certified at level 2 or above. And no one here is certified to level 2. I'm not. Mark's not. We're both level 1. Christine, Connie, we're all level 1. So that's why we need someone level 2 in your local area.
I'm level 2. Aaron.
Christine's flexing on you, Aaron.
Oh, what was that?
She's flexing.
I said I am level 2.
Oh, I didn't know that.
Yeah.
You're in trouble, Aaron.
Guess I am.
Hey, Andrea,
Yes.
do you want to break out into a separate group so I can help you out with this a little bit?
Sure. I'm still standing.
Yeah,
I'll join you.
sounds good.
Let's see, and for propulsion, if we could go on to the next slide, I just want to show you an example of what these motors look like. And I know you guys probably have your handbook turned to a different page, but page 22 has some pictures of example motors. There's like Cesaroni and an Aerotech kit, but they can be single use or reusable ones. The ones you guys will be using are single use. That's that figure 6.4, the black one with the yellow nozzle at the bottom. And all those components inside, it's the propellant grain, all the O-rings, those are all pre-assembled, and all you need to do is stick that igniter in and then put the black powder for the ejection charge that'll kick out your parachute in, and that's it for the single use, and then you have to throw it away afterwards. But they make metal casings that you can buy the individual propellant grains to put back into there, and you have to install the O-rings and nozzle yourself, and you have to clean it after each flight, but you are able to reuse that casing and buy the propellant grains at a slightly cheaper price. It's still not that cheap, but those are the different types of motors. There's Aerotech, Caesaroni, Animal Motor Works. There's lots of vendors, but you guys will be using an Aerotech H219 single use. And
I mean,
and one thing that's useful for you are ensuring you have enough motor strength to get you into the air safely is the thrust to weight ratio. That's where you take the weight of your rocket from Roxton, like it'll say like 1,000 grams total, like that's your mass or weight of your rocket, and then take your average thrust, so it's in pounds or newtons, you can convert that to pounds, and that should be at least 5-to-1 or higher is better. Like if you have 4-to-1, like your motor only gives 4 times the amount of thrust that your rocket weighs, you won't get a stable flight. It's not enough power, and it'll kind of fizzle out or not be stable. So above 5-to-1, 10-to-1, 15-to-1, 20-to-1's kind of high, but in that range. And to find that average thrust, these thrust curves are kind of helpful. I mean, we don't really use these kind of graphs, but it's the information that comes with the graphs. That's like the burn time, max thrust, all those things on the side, but it's the average thrust. Don't use the max thrust for the thrust to weight ratio. It's average thrust. That's something I think is important to remember, average thrust, and make sure your units are correct. And the rest of the stuff in the handbook kind of goes into RockSim stuff about your trajectory analysis, and that's kind of a topic for another time. But later today, when we take another break, I'll go through RockSim and show how to do a simulation using a graph like this. Did you guys have any questions about motors or propulsion or anything like that for this workshop or the competition? I think I'm okay. We still have many hours of this workshop left, so you can always ask.
All right, so I want to go back real quick and see if you have any questions about this step, because we're about to move on. So I see people are still putting their motor mount into their airframe.
yeah, how's everyone's motor mount to airframe coming along? Hopefully you guys got it in there. If you find it's really hard to push, it's because you waited too long and the epoxy's already cured and set up. So hopefully you guys got it in there, within the 5 minutes before that epoxy cured.
And just making sure again that your mid-centering ring is just forward of the fin slot, and it's not interfering with your fin slots at all.
And you do want to make sure that it isn't way beyond the fin slots either, so that your motor mount tube is too far up in.
What happened? I got kicked out.
We still hear you, Mark.
Yep.
Yeah, your aft end of your motor tube should be almost even with the aft end of your airframe once you have it lined up.
This part here, right? The apps, the two tube should be almost flush. It's okay if it extends a little beyond or it's a little further inside, it's all right, but.
Right.
The important part is that the mid-center ring just clears the slot.
So giving a thumbs up. Tyler, I think yours looks like it should be good. He's about a 1/4 inch in. Looks like.
Looks good, Jason.
Yep. Anthony, can you turn yours to the side just so that we can see how far up in the tube that is?
Looks good, Scott.
Okay, so his looks like almost a little bit more than a 1/4 inch. Is that fine?
Yeah.
Anthony's? Okay.
As long as that ring clears, he might have got the distance wrong when he attached the center ring to the bottom mount tube.
Okay. Yep, yours looks good, Willie.
D'Angelo, looks like your tube is in there pretty far. I can't tell.
Aaron Yazzie, yours looks good.
Your motor mount tube looks like it's too far in there, D'Angelo.
Did you push it too far, D'Angelo?
No, it looks like it's only about like 1/2 inch above the end hole or like the fin part.
Yeah, so your ring should just line up with that slot, like not beyond it. If you're 1/2 inch past the slot, then you've gone too far.
Can you still move your motor mount yet?
Yeah, I can.
If you move your motor mount back, is the mid motor mount ring blocking? Is it block? What about your mid motor mount ring and your top of your fin slot? Where's that at?
It's just above it. Well, not because I pulled it back. Now it's just like above. Now it's way closer.
Okay.
All right, that looks better.
Did you feel like sorry, really quick, D'Angelo, did you feel like the epoxy is catching the forward ring? Because now that you pulled it back, maybe you don't have as much epoxy on there.
Yeah, there's that concern as well, but.
Yeah, it looks like you might have to do re-epoxy.
And those of you that are done, make sure to clean up your areas, clean your epoxy, clean your hands, make sure you didn't get any epoxy on the airframe. That was a big step. I got epoxy all over.
Did anybody check Nikki's? Hers looks like it might be back a little bit far. I can't see. How far back is that, Nikki? Is it a 1/2 inch? Is it just a 1/4 inch? Okay, that's better, it looks like. Okay, thank you.
All right, can you see it better? It's just almost flush with this outside area.
Okay, perfect.
So
the way
that
the lighting was, it looked like it was farther back.
That mid-center ring should sit just in line with the front of that slot.
You have some mail.
Not 1/2 inch past, not 1 inch past. Just in line with the slot.
How do we check that, Mark?
Just by looking through the slot, you should see where that ring is for the students, right? Try and get them to show you or tell you where it is, but.
I got a way to double check that, but I don't want to confuse anybody. Or I don't want to be out of line.
And we can, by observing, we can kind of tell by looking at the tail, if we see that the tube looks to be 1 inch too far in, then it's probably your ring is too far in as well.
It looks like we lost Andrea. Andrea, are you checked in as Becky Green?
No,
He's in a
she's
room.
in,
She's in a
she's in
breakout room.
breakout room.
Oh, she is. Can you tell me who you are, Becky? I've been trying to message you.
Oh, that's the mentor for UC Davis.
Ah, thank you very much.
Now I'm logging in again, Connie.
All right. And then we have about like 10 or 11 people who are done with this previous step. So once you're ready, Frank, we can start with this current coupler and sustainer slide.
Okay. Everybody grab their coupler. The coupler is the one with the bulkhead and the eye bolt in it. And your coupler should measure approximately 6 inches long. If you take your ruler and measure, it should be 6 inches long. Take half of that, which is 3 inches. And mark it at the 3-inch mark, like probably 3 spots on that coupler every 120 degrees. Mark it.
So we're just putting marks at 3 inches around the tube.
And once you've marked that, I wasn't listening, Mark. I had my volume down because I was messing with the computer. It's generally a coupler is the gets inserted inside the airframe the same diameter as the rocket is. So if you have a 3-inch rocket, which you have, the coupler is inserted 3 inches into the airframe. If you have a 4-inch rocket, goes into 4 inches, and usually end up with an 8-inch coupler.
So once it's marked, you can dry fit it into the little sustainer tube.
Perfect, Willie.
And if you have a problem trying to get it, if you have a problem getting it into the sustainer, don't force it in to get a burr. Because I noticed these kits only accept one way on it for some reason. And the part you have the black laser cut on it, there's a razor cut on one end and there's a laser cut on the other end, which is black. The coupler fits in a lot better on that end if you have problems.
Yeah, try the other side as well. If it's starting to jam or something, maybe just flip the tube over.
Yeah, the nose cone will fit better on the side that was sawed off compared to the side that was lasered off.
And Frank, can you repeat how they're going to be able to tell the difference? The sawed off side is the black.
I mentioned that one. The laser side is black, burnt, and the other side is hand sawed cut.
Okay, perfect. I just wanted you to repeat it.
Yeah.
Thank you.
And make sure it goes in that 3-inch mark where you have it. Can you get your coupler inside your sustainer section? There you go. You got it, Christian. That's good. D'Angelo, you got yours?
I'm marking it.
You got to mark it yet. Yep.
Laser and razor. That's a nice rhyme.
And right, the laser end is where it's burnt looking on the end.
All right, step 3.
Once you get your coupler mark at that 3-inch mark in 3 spots or 2 spots, as long as it's equal, mix some epoxy up and apply some epoxy in the internal part of the airframe of the same end you put the coupler in, so you make sure it goes in.
Just around here, maybe about
You are
an
gonna
inch
need to-
in.
Put
You're
about
gonna
an
need
inch.
to pull your coupler out of the so that you can epoxy. I see a lot of you still have it in.
They're putting their gloves on and
Yep.
getting their epoxy ready.
Yeah.
An interesting way you can tell if you've actually been doing one-to-one is after a few epoxy mixes, if you compare the levels of both your bottles, is one lower than the other. I found that I do more out of one bottle than the other, so it's not good, but my rockets have still flown. But one-to-one mixture is always the best.
Mark is showing step 4 right now.
Come on, come on. Come on.
Testing 1, 2.
Come on, play nice, play nice. There we go. So once you get it in and seated, just twist it as you insert as well. That'll spread the epoxy evenly. And then you want to stop at the line or the 3-inch line or marks that you just created. Looks good, Jason. Willie, you're done? Looks good. Aaron looks good. Anthony's good. And you want the bulkhead on the outside as well. I think people have made that mistake before and they put the bulkhead side on the inside when they put it in. Looks good, Scott.
Taylor's your eyeball. Oh yeah, there we go. Perfect. Looks good.
Hey, Aaron, what launch vehicle is your JPL mission using on the 18th? I'm just curious, the hobby equivalent.
Say that again. I heard JPL.
He doesn't know the launch vehicles. He just does payloads. He doesn't care about the rest.
Yeah,
It's a ghost.
I don't know.
It's his black box. That's
Just get me there.
Yeah, it's a black box.
It's true. I don't really know what it's Atlas.
He doesn't know them. He doesn't know rockets at all.
It's really embarrassing sitting here from the NASA Jet Propulsion Laboratory learning about propulsion of these rockets.
Learning about rockets. Did you tell your colleagues you were building a rocket this weekend, Aaron?
It's an Atlas V rocket is what we shot at.
You got to take it to work. Show your colleagues there. Put it up behind you on the wall and be like, I built a rocket this weekend. I don't need you guys anymore. I can build my own payloads and rockets.
That took my level 1 kid into Reiki.
So I can launch the next one. Yeah.
How's everyone else doing? Marlon, how's it coming? Did you get it? Yeah, looks good. Nikki? Yeah, looks good. Tyler's just getting it in there. Looks good. Twist, yeah, twist it, Tyler. There you go. Spread it. Yeah, it spreads the epoxy around when you twist it like that. Oh, you're dripping all over. So grab the wipe there, the alcohol wipe, and try and wipe up. And it goes for all of you. If you got excess epoxy on the end, the edge, or make sure to wipe it up right away with your alcohol wipes.
I think at this point, I think everyone understands this step. So we're going to keep our eyes on the chat, but I think for those of you who are ready, we're going to move on to some rock sim simulation.
For anyone who's curious, the Alice 5 would be an A motor, and that's 15 times double a 15 motor you can use.
All right, Aaron.
Sorry, I was on mute. Danielle, could you bump Andrea and Bob and I back into a room so I can catch her up? I didn't realize you guys are a full step ahead of us now.
Yeah, no problem.
Okay.
Yeah, you can, Kevin, you can just text me. Sorry, Kevin, you can text me if you want to know what step we're at, or text anyone.
We'll get through this fast.
Okay. Sorry, go ahead.
The next step of RockSim will be to put the motor you guys will be using into the simulation. And to do that, we'll need to move a few components around. And I know you guys' hands are busy with the hardware. Not sure if we're expecting you guys to actually do this in RockSim. If you are available to, you'd be welcome to as well. But thrust curve, that's where you can find all the data, like those graphs of the thrust over time, as well as the average thrust and info like that. And we won't need to be doing that because RockSim 10, which you released this year, has a way to search within their tool, so we can use that. But we linked a video. We won't be watching it from start to finish, but it's a good reference on how to use RockSim to load a motor into your rocket. So if we could go to the next slide, that'll just show a overview of what the RockSim screens are, and then we're going to switch to viewing my screen. Let's see. Sharing.
All right, so for those of you who are done with the sustainer part, go ahead and pull up your RockSim, and I'm going to drop the thrust curve link in the chat for you so that you can follow along with the steps that Aaron is doing.
Yes. Thanks. So you guys had downloaded that lock caliber ISP.rkt file yesterday. So once you open RockSim, you can go ahead and open that. I have mine saved here, so I'll just open it again. No changes. So if you had downloaded it yesterday, you should be seeing the same thing as I'm seeing right now.
Hey, Aaron, can you make that screen a little bigger?
Hey, you have full screen on there?
Can you expand that? There you go.
Thanks, bud.
So this should look a little familiar. This coupler right here, you guys had put that in. Some screens. Screen. That upper tube in blue there, you guys had epoxied that to the coupler. It's called section coupler here. So let's get that bigger. This one right there. Our diameter is 3 inches. That's something you can measure. And we put it 3 inches from the base of that tube, and you can set it in RockSim, this location that's inches from the bottom of each part, the bottom of the coupler or the aft part of the coupler to the aft part of the top body tube. That's how it's measured. So minus 3 inches, it's 3 inches sticking out of the tube, which is what you guys epoxied just now. But to show you guys where the motors are, this default kit, it's motor mount tube right here. It puts a 54 millimeter motor, and the one you guys will be using is a 38 millimeter. It's slightly different. So that's something we can change, but I just want to show you where we'll eventually load a motor. So load an engine here. RockSim only shows that with motor mount tubes, and if you put a plain tube in, you can check this box that says motor mount tube. And then the other way to see the motors is if you go up to your flight simulations, and actually you don't need to do that. Cancel that. On this top bar, it's this icon with the base of a rocket with 2 wires in it. That's the prepare for launch. And there's this choose an engine button. So that's the 2 ways you can choose the engine. So I'll pause there for a bit, see if you guys understand that. And then I want to modify this tube here. Mark sent me his dimensions. I'm going to try to match them to this model. So this motor mount tube, it's lock precision, so that you can go to this database and they have, RockSim has lock precision parts in here. So this one, 54 millimeters is 2.14 inches, so MMT-2.4, that's a motor mount tube for 54 millimeters. So I'm just gonna change that to the motor mount tube for 38 millimeters, which is 1.52 inches. So I just I scroll by manufacturer, their lock precision. This is my old one. Lock motor mount tube, 2.4 inches. That's too big. So the one you guys have is this one. Lock motor mount tube, 1.5 inches. So I'm gonna double click that. And as we can see, it's put in a 34-inch tube, which is not what you have. So I believe it's 17 inches is what you guys have. So I'm gonna change this to 17 inches just to make it more accurate. You can either drag that or put the number in here. So 17 inches, that's correct. It's still a motor mount tube. And here there's forward and aft centering ring. So that's a good start, but we have 3 centering rings. So I'm just gonna check how they measured these. So this is the forward centering ring. And they put it at 10 inches, I think. Mark, I think you said yours is 11 inches, so I'm just gonna change it to 11. And that just puts it forward a little bit.
It would have been like 16, 11 plus the 5.
Oh. Put it at 16. Oh, yeah, that looks better.
Is that the right one? did you mix them?
That was the right one. Aft one is the one at the bottom of the rocket. That's the one with the T-nuts, I think they're called.
Yeah.
And this was a 1/4 inch, I think. So oops, put 0.25 inches, and it's kind of
You
weird.
can also, you could slide it to just butt up with that tang as well.
Yeah, I'll probably just do that. It should be. Yeah, just put it to be flush with the fin tab there. And then I'm going to select this main airframe to add a coupler, or sorry, add a center ring. And then it's a 3-inch rocket and a 1.5-inch motor mount. So I'm going to choose that. And then here it is, that mid-center ring. And locate that at the top of the fin tab. Okay. So to actually load the motor, open your motor mount tube. My other screen, sorry. Computer froze. Okay. So I'm going to go ahead and go to load engine. And then ideally, it would be in this list. So I'm just going to check this option, show only engines that match 38 millimeters. And then I'm going to sort by engine code so I can find H219T. Oh, James, load engine. I'm clicking the motor mount tube and then going into that window, and then it goes on the other screen again.
There's multiple ways to load engine too.
Yeah. This multiple screen thing is annoying.
The drop-down menu at the top says, I think simulation will have load engine. The icon, that icon right there, you can also load engine. So H219T is not in here, so I'm going to close out of that and then go up to File, Reload Engine Data, and then this tab is Roxanne's new tool. Common name is where you put the H and number, so I'm going to put H219 and search, and it found one component. That's your motor there. So go to highlight it, go to download selected engine data, it downloads it. Nice.
Save it to this location, and this is where Roxanne is installed, so that's okay. Save. I already downloaded it, so I'm going to replace it. And then you have to go back to this engine data files. It'll come up here. Actually, let me remove it just so I can show it. It'll come up here. You have to highlight it and then click add. So it's under your selected engine files. So once it's there, you guys can click OK, and then we go back to load the engine, and it should be there. Hopefully. It was earlier today. There it is, H219T. So we can go ahead and load that. And it showed up in there. And I believe that was all of what I was going to show now. That simulation would be later, but I mean, Launch it and these.
Yeah, you forgot to take the plug out.
Oh, good point.
There you go.
Plugged. 14 is the default delay, but for mine, I cut it down to 10 seconds. But we have a special tool to drill it out. And then I'm just going to go through this kind of fast, so I apologize. It's a 6-foot rail, so 72-inch rail. Launch condition. I'm just going to leave all this. Position settings. Flight events, deploy at max delay. Yes, that's motor ejection.
And just for the interest of time, I know people are having a hard time keeping up with it. So maybe what we could do is maybe Aaron can record himself doing a Zoom walkthrough with this, and we can upload that separately for loading in the motor. We also have a video that's already accessible through the link on the slide that we were showing.
Yeah.
Yeah. So just because we're about 15 minutes behind on the build, and we want to make sure you guys get a full 30-minute lunch.
So just quickly before we do switch over, let's answer the one question. Just repeat the removing plug part, if you wouldn't mind, Aaron, and then we'll move on.
So go to load your engine after you choose it. The default is plugged here, so you change that drop down to 14. That's removing the plug. And that's, you can change that number too. So.
And we only change that if you are, like you said, drilling out and changing the ejection charge, right? I'm having a brain freeze.
Changing the delay time on the ejection
Delay
charge.
time. Thank you.
On there, level 2. You know your stuff.
On that note, all right, are we ready to go to the next step then?
Okay, let's see if we can fit that nose cone on the sustainer that you glued the coupler on. Does everybody have a drill with them? Either a hand drill or a power drill? And also, you should have a self-tapping screw with you also with a Phillips head on it.
Oh, I didn't get that.
No, they didn't get a power drill.
No, that's self-tapping screw.
They did have a hand tool that they may need to use if they do not have a power drill.
I did say, do you have the hand drill or do you have a power drill? Get that out and use it. Use the largest drill bit on your hand drills. Insert your nose cone into your sustainer. Make sure your shoulder of the nose cone goes all the way into the sustainer.
Some of them are loose. Mine wiggles a little bit.
Yeah, these black ones are pretty tight on them. Pretty good fit.
Yeah, last year's model wiggles.
Yeah. And if you have your drill out, your hand drill or your power drill, we only need like an 1/8 to 3/16 hole drill bit to drill a hole into the airframe and through the nose cone shoulder just to get a hole started. And you need it only about an inch down from the shoulder of the nose cone into the airframe.
So about an inch down from where the two join together, and make sure they're held flush together.
Do you mind showing how to use a hand drill, please?
Oh, the hand drill, there's a chuck on the end. Do you have the drill bit? Who is calling?
Yep, Maria.
Let me find you here.
I'm sure a lot of them need the instruction on the hand drill, Frank, so just
Yeah.
demo. I don't have it, so you guys will have to demo it.
Yeah, I don't have a chuck with me too, but I have a drill that has a chuck, the same principle as your hand drill does. Well, you have to spin the top of the chuck open so the jaws open up and insert the bit in there and then counterclock or tighten it up right-handed like a lid to tighten up the chuck onto the drill bit.
Anthony, do you have a power drill?
So I got that, but then how do you make the force? Like, does it have a spring or something, or you just?
No, you have to hand turn it in. Take your drill bit and push it down onto the spot you want to drill. And the end of that drill, which I'll give you an example on a screwdriver like this. Just push down on there and just turn it. Push down, turn, keep turning it and pushing down on it. A lot of force.
Okay, thank you.
Yep. Takes a little time. The worst part is probably trying to go through the plastic on the nose cone, but use a lot of force. Put your sustainer and your nose cone all together on the table and push down on a stable spot so you're not like.
Yeah, Anthony, you could use a screwdriver or something, whatever you can to get the hole in there. This drill step is also, you could do it after the workshop, perhaps. There are other drill steps we'll do here in a bit that need to be done today or should be done today. So for those of you who don't have a drill.
You should have
how big should the drill bit be?
You should have actually people that have a drill bit with a Phillips screwdriver on it, the drill driver, you should be able to drive that self-tapping screw right in through that airframe into the plastic. You have a power screw driver.
So Anthony, yeah, if you have a screwdriver, just use the screw that came with the kit and you should be able to just drive it straight into the,
right,
without drilling the hole.
Andrea, did you hear that?
Yeah, I gave Anthony and Willie those drill bit sets that they're describing.
Well, you can take that self-driving screw we were looking at and you can put it right in where you put your dot right now with a screwdriver.
Okay.
And when you say self-driving screw, you're talking about the one that looks like a wood screw?
Yeah, it looks like this. It's got a little
point.
Little drill bit at the end.
Oh, I don't think I have that.
Yeah, some of them may not have. I don't have it either. Some of them may not have, but you don't have a drill, Aaron?
I have a drill, but if I don't have that, then I don't have the fastener that holds the two together after I drill the hole, right?
It'll friction fit between both the airframe and the nose cone.
Yeah, he just also doesn't have the drill. See, I'm just using some, this was my screw I found in the garage that I'm going to put in here. So,
okay.
It doesn't need to be the specific self-tapping one that they're describing.
Right.
Okay.
As long as you have a hole and you can get a screw or something in there. All right, turn it by hand even once the holes in, once the.
Right, once you get a hole started, you should be able to
you can just turn the screw in by hand.
Parker's asking what size drill bit is it?
It's a 1/8 bit. How's everyone coming?
Yeah, once you get that hole drilled,
the thing goes in there nice, yeah.
Yes, it does.
So if you don't have a drill, again, you can just probably drive the screw directly in without the hole.
Right. Takes a little work.
A little bit of work.
Just as much as work as trying to drill it with the hand drill.
And then whether you got the hole or not, just drop that screw in there and join your two pieces.
And the reason for this, no, it's going to be attached with this screw so it does not fall off during the flight, because it will wiggle off.
It's the pointy screw, Anthony. Looks like a wood screw. That's it, Willie? Yeah, I think that's the one, yeah.
There are two of it came in this little bag. Just wanted to make sure I'm not using them for anything else.
Sure.
No, yeah, that's right, yeah.
Okay.
Where's my little camera there?
There should have been a screw in your supply list in your little baggie with your gloves. Should have been
Get
some
in there,
screws
Tyler.
and with a quick link too.
I actually might have the actual screw in the other.
We just have a couple more minutes on this step. So
Oh, yeah, there's
please
two.
put an R in the chat when you're ready to go on.
Yeah, your kits would come with two of the screws, so mine are still in the bag. I do have the same model you guys have. So you can see those are the two screws there. And isolate those away from the other screws. You'll only need one, but
Looks good, Aaron. Taylor's got it in. Anthony's got it.
I think those extra wood screws were for in case the T-nuts didn't work. You could screw it into use that instead of the T-nuts. You just put in extra screws for that.
or if you're really worried about your nose cone coming off, you could put a second screw.
Or you just put a massive amount of masking tape inside of it. Everybody have their nose cone secured? I see a couple R's. Looks like everybody did well. Marlon, how you doing? Okay. James, you guys okay? All right, excellent. Taylor, are you doing your homework? Okay. Thank you.
I think Christine, if you could put the motor loading video in the chat, because Taylor needed that to catch up from before.
Which video did you need up?
The motor loading video that we referenced a couple slides ago, just so that people can take a look at it during lunch if they need to.
I'm going to be honest, Danielle, I don't know what you're asking me for.
You mean the motor mount?
On slide 38, when there
About
isn't
5 minutes
an
ago, we were
exact
talking about
match. RockSim tutorial adding motor data files. Could you put that in the chat for me?
Is Connie on? Connie can grab it.
Connie's got it.
Connie knows more what's going on.
All right, I think for time, we want to make sure you guys get to lunch by 12:30, so we're going to move on.
Okay, this particular rocket has a 1010 rail system that goes on a 1-inch square rail. And the rail is approximately 6 feet long or 72 inches in length. The object here is to mark the middle of the airframe between the fin slots equally, because that's where you want to put the first rail button. So you have to mark a line halfway between the two fin slots, one at the aft portion of the frame as exampled in the picture in 13.-14 in the lower left-hand corner there. And there is a video. You have a video there, Daniel, on how to.
Is it acceptable to eyeball that, or I could demo the video?
Sure.
Yeah, we would want it to be done the exact marking way. So if you can do the way that the video did.
Yeah, I can do that. So I think Kevin posted the, let me try and get it.
Yeah.
So usually, sometimes you can eyeball the middle to get your mark between those two pin slots. Another way to do it with a piece of paper. Can you guys see that? Is to just go from one fin slot edge to the other, mark a line. Fold that in half.
Freezing up.
Yeah, I can see the vid. I can see on my monitor too that the other. What happened?
So just halfway between the two fins, right?
Yeah.
Yep.
So if you can measure between the two fins and then mark it more precisely.
I'm gonna, since your video's frozen, I'm gonna just pull up the video that we have, okay?
Not bad.
Yep. There you are.
So another way to do it is just take the piece of paper. You know, everyone's got paper laying around, scrap piece of paper. Go from one fin to the other side, mark a line. Oh, we're playing the video or no? Fold it over on that line, and then that's your midpoint, right?
Yeah, watch the video. It's coming up. There's your piece of paper.
And then if you translate that back, that should be the center of the two fin slots.
Right. Just keep it on the inside of each fin slot. Mark it. Fold your paper in half to that mark you marked. And that's your center. Line it back up from the inside fin slots to the inside fin slots. And where your fold is, mark it on your airframe. You can do it on the bottom half of the aft part of the rocket and at the top of the fins. You have kind of a reference mark.
Yeah, so you could mark 2 points, right? So mark one down here at the bottom of the slots and one at the top of the slots.
Anybody got a door jamb?
Everybody should have a door jamb, but I'm going to use a window sill here, Frank, for the demo.
Oh, yeah. There you go.
My window sill actually lines up and it's right here.
Excellent. Now you got to hold your camera in your teeth. There you go. Either a door jamb or a windowsill. Mark up, line up your mark. And take your pencil and draw a line from where you mark the center of the airframe using that piece of paper and draw a line straight up just like Mark is doing. Straight and even. And you have established a straight line on your airframe to mount your rail buttons.
You guys don't have to get up and go to your door frame, your door jamb. And if you put it in the little, you know, there's a little right angle, there's a little ledge there. Your door jamb. And you should just be able to draw a straight line. Use the door jamb as a template.
Right. The door jamb is actually the door stop, or you can use the molding on the side that meets the drywall. But the door stop on the door works the best.
I go, Tyler, you got a straight line, the whole length of the airframe? Looks good?
I'm trying to see everybody do it.
Yeah, they're gonna walk away from the camera to go do it and then come back.
That's right.
So I've got a nice window ledge here that also works. If you've got that too, if you got like an overhanging window ledge, you can just use that ledge as well.
Nikki, are you showing us your line? I can't really see it. It's just the video quality.
Yeah, it's there. I can see it.
Thanks.
Yeah, Nikki's got it.
Doesn't need to be super dark, but dark enough that it doesn't wipe off in the next couple of steps or hours.
Just got to make 10 minutes.
All right, Aaron. Aaron, you got yours. All right. It's good. It's good. Marlon, you're good. All right.
Everybody got it, huh?
Where did Taylor go? Taylor's gone. She must got a really big garage. She had to walk quite a way to get to the door. Frank's got his camera on his.
I got the door jamb right there, and here's my mark, and you just draw a line right up the door jamb or the door stop.
I think everybody's got it. All right, Taylor, looks good.
I think we can move on to the next step.
Lily, it looks like you're darkening your line.
Oh, the vent holes. Where's Frank? Frank, are we
Right
there?
here. I'm here. Okay, we need to get your drill out, your hand drill or power drill. And we need to drill a couple vent holes. The holes actually kind of go, you can drill them it doesn't matter where you want, it's user's preference. And what we've been doing is putting it in the middle of the booster, in the middle of the sustainer area. This is to equalize the pressure, the internal pressure of the rocket and the external pressure of the rocket as the rocket ascends, because pressures change and your rocket could prematurely build up pressure inside and eject on its way up. And we don't want that to happen before it's supposed to eject at apogee. So drill the first hole in the middle region of the sustainer. We just need a 1/8 inch hole. Is big enough just to equalize the pressure, the inside pressure to the outside.
How do you choose where to put the hole? Maria is asking in relation to the screw.
Up to you.
It's up to you. It's user preference. As long as it's not in the shoulder of the nose cone, but it should be in the middle of the sustainer and the middle of the booster.
Not in line with your rail buttons.
That's right.
I like symmetry, so I try and line everything up. I'm going to line up my hole with the with the screw that we just put in and try and get it in the center.
All right.
And you do want to make sure that you're avoiding the centering ring, am I correct?
Correct.
Oh, we were doing the sustainer first, but
Well, right, when we go to the booster section, just making sure that we don't drill into that.
And I know that there are a few people that don't have drills with them right now. If you maybe want to take a pen and just mark that spot so you remember to drill it later, as long as it's done before you fly it.
And don't drill it when you have the parachute packed in there either.
But Willie, you're doing great. I saw you trying to use the small hand drill and making that spot. So good job.
Yeah, the hand drill is a little chore, but you have a drill. We supplied a drill for you, and it works. Nikki, how you doing? You get the hose? Oh, nice. Excellent. All right, cool.
Nikki, do you still have your daughter? Is it your daughter watching you? Did you
No,
say?
actually, my daughter was super bummed because she's at her dad's right now.
Oh no.
Yeah,
Bummer.
so I have to send her a picture.
Awesome.
What distance did you drill that second hole there in that other sectioning of the tube?
In the
and it's
booster,
kind of arbitrary, Andrea. So you can put it, maybe 6 inches down from the other edge.
Okay.
And is that hole supposed to go on that line we just drew, or can it?
No, anywhere
No?
around. You prefer not to go on the line.
Okay.
Right. Yeah, that hole has to be in a cavity where the recovery and parachute sits. Don't drill the hole where the motor tube is.
So you want it to be above that motor mount centering ring, right? Which is probably like a good 12 or 18 inches in there.
Right.
So 6 inches down is sufficient.
As shown in 13-15.
And I got a question. You can see with these cardboard tubes, the seams where it's twisted. Would you prefer that you don't drill at the seam?
no, it doesn't matter.
Doesn't
No,
matter.
the seams are fine.
Seams are fine.
Is that even a real seam?
Repeat where the vent holes should be again. I just got asked for that. Frank or Mark, can you just repeat where the vent holes should be, please?
In the middle of the sustainer and halfway in between the booster.
So it's exact middle of the sustainer. I lined mine up with the screw hole.
And to repeat, do not drill the hole on the line that you did for the rail button.
And then for the sustainer, you're away from the fin slot side. You want it on the other side. And about maybe 6 inches down, 8 inches down from the edge. You're just putting another hole. And you're staying away from the line we just drew. So it could be anywhere around. You got 359 degrees of choice.
Right. Yeah, they don't have to be lined up as you see in the picture.
I mean, when you join the sections together too, they will rotate relative to each other.
Maria's done. Crescent's done. Angel's done. Everybody's done. Anthony, how you doing? All All right, excellent. Seems like we might be done. What's it look like to you, people? Are we
Yeah, it looks
happy?
like almost everybody is done. So we'll do a few reminders. So this morning we've been able to complete the motor mount, complete your coupler and your sustainer, your nose cone, your rail buttons, and then we will start the fins after lunch. And so between what we'll do is we'll restart at 1 o'clock. We'll need to be, right on time, like we talked about before, so that we can get started on those fins. That's quite a lengthy process. So you do not be late. If there's anybody who is having any trouble with this final step or feels like you have not completed everything, please stay on and we'll stay for a couple of minutes to make sure you're good to go for when we come back at 1 o'clock. Feel free to leave your Zoom on if you'd like. Go ahead and, you can turn off your camera, turn off your sound, and then just rejoin us again at 1 o'clock.
Yeah, just to clarify for those in California, that'd be 11.
11 o'clock. Yeah, 1 o'clock at Christine's time.
Yeah, 11
Sorry.
11 a.m. for those in California, so everybody in Davis.
What time in Hawaii? Like, go have breakfast now in Hawaii.
Yep, it's on the screen. The screen will stay up as a reminder. So we have both times on the screen for you, wherever you're at. I know we just don't have Chyson's time.
Tyson and Nikki. So, but excellent job this morning, everybody. And we'll see you back in, let's do this. We'll see you back in 43 minutes. Okay, folks, it is 1 o'clock. So we are going to go ahead and get started. This afternoon, as I said earlier, we're going to be doing the inner and outer fin installation with our RockSim updates as we go along. We'll be adding our aft centering ring, our rail button installation, recovery installation, and then and parachute preparation, and then going over our certification launch guidelines. So a couple of things to note, please stick through all the way to the end because we will have a survey at the end that we are going to ask you to complete for us so that we can evaluate the success of our program. So my question is, before we get started, does anybody have any questions before we move into the next step? Any questions? Okay, I'm not seeing anything in the chat, and I don't believe I'm seeing anybody raising their hand. So with that being said, we can go ahead and move on. Frank, you're going to go ahead and start the fin installation, and as you get going, everybody should have the fin installation, the reference sheet, the guide in your books. To be able to take that out, you're going to need that. You're going to need to put it on a flat surface and typically below your waistline. So on the floor is a really good place for it.
Well, good afternoon and welcome back, everyone. We're going to do a dry fit again, and I'm going to be tacking the fins to the airframe mounted to the motor mount. You want to grab your fins and dry fit them all into your airframe. And also, we need to go towards the rear of your handbook, and there should be a fin guide template for you to use to line up your fins. And it's probably better off if you open your book up and instead of tearing it out, just undo the tabs and pull it out, because you probably want to keep it in there for reference for later on. So dry fit your fins into your slots and retrieve your fin guide template, please.
Page 67 of the handbook.
Yep. Make sure all your fins fit properly. If not, let us know, because you may have to sand them possibly. And if you have a problem getting them in the slots, you just need to sand the slots. It's just a pre-fit in case you dropped any epoxy in the slots. So if they all go in and they bottom out and touch the motor mount tube, you're good to go. I don't have a printed handbook.
I thought you said that to you.
Yeah, I don't have the. I just don't have that the rock guide or the fin guide in a paper form. Could I be able to just make a?
Oh, you don't have that in your handbook?
I don't have I never got a printed handbook. I just have a PDF version of it.
Yeah. Do you have a tiled floor?
Unfortunately, no.
Do you have a printer handy?
Yeah.
No.
Yeah.
I bought it. You'll be all right.
Okay.
You're a payloads guy. You whatever.
Yeah, you got a good eye, right?
Sure. With the right glasses.
Yeah,
And
I
I
think
shared with
Aaron,
Mark
just
that
so
I
you,
had a hungry dog this morning that chewed part of one of my fins.
Oh yeah. Yeah, Scott's got fin damage, so I just kind of told him it's up to him if he wants to install it.
oh wow.
I mean,
Aaron, just so you know, I think it was because you might have been a later ad, and so we did not send the booklet to you. My apologies for that.
yeah, looks good, Andrea.
Oh, I'm trying to think what he could use.
So there's the one with the fin damage.
It'll fly, Scott. I don't know. I don't know how Frank and Bob feel about it. I'd go ahead and do it.
Yeah, the fin guide slots are pretty accurate. You're just gonna have to make sure they're all perpendicular to each other, straight up and down. You know, if you put two fins on across from each other and they look straight, they may look straight until you put the other three on.
I mean, we've seen some bad fins.
Aaron, if you have a piece of paper, and you draw a straight line, do you have anything that you would be able to do a 90-degree angle?
You got a little, you got tools or anything there, Aaron? You could just.
Yeah, I think if the idea of the guide is just to make sure the pins are, or the fins are.
Yeah, you just want 4 90-degree angles.
Okay,
Yeah.
I can make sure of that.
You can also just fold a regular piece of paper, symmetrically 4 ways.
Yeah, that works too.
Yeah, that too. Yeah, right. You could fold it in four pieces and draw a line in the creases and flatten your paper out, Good idea. Who was that?
Andrea.
Andrea, nice work.
All right, are we ready to?
Everybody dry fit their fins? Do they work okay? They go in? What you want to do on your fin guide is to get it waist high or put it on the floor, because you want to look at your rocket from the top, the forward part of your rocket, to line up the fins. It's a more accurate way of looking at your fins, to line them up if your fin guide is on the floor, because you're going to end up putting your rocket on top of that fin guide. And it has a 3-inch plus circle to resemble the diameter of your rocket. So make sure that airframe is riding on the edge of that circle, and your fin slots are lined up with those 90-degree lines. Everybody got their template on the floor? Looks like someone's drawing one.
And so I'm doing mine on the table so you guys can see my camera angle here, but preferably on the floor.
There you go. As long as you got your fin guide on the floor, you're good to go, and your fins are inside your rocket and they fit fine, you're good. The next thing is to mix some epoxy. Mix enough epoxy where we're going to be applying epoxy to the tab, just to the tab of the fin.
Next slide.
I'm sorry, keep calling it a tab.
The tang.
The tang. Of
Or
the
tab.
fin.
It says tab in other, I think it might.
Tab, ting, tang. Root, whatever. And we're just going to apply epoxy to the edge of that. Before you apply the epoxy, maybe you want to tear off about maybe 12 inches pieces of masking tape if you need it to straighten out your fins so they stay where you want them to stay. It's a good idea because if you have a very loose fin slot, when you put your fins in and you put your airframe up, the fin might fall out possibly. So you want to get ready with some tape so you can stick the tape to the fin and the airframe so it stay there, and line it with the lines on your fin guide.
So maybe like 4 6-inch pieces or 4 8-inch pieces should be enough.
Yep.
Get them ready in case you need them.
Just hang them on the side of your table.
Scott, I think one fin of yours is going to be very loose.
Yes.
You might want to have an extra piece of tape for that one.
He can put on that. He's going to put that fin on, isn't he? The one that's just chopped on in. Yeah, that'll work.
I can already hear the interesting names of that rocket now.
Right. I can see the RSO looking at it too.
My dog ate my homework. So epoxy along just this edge, that little narrow band.
Yeah, you just want to butter the edge of it.
And
So we're going to tack the fin on. We're not going to like super glue it on. We want to tack it on there so in case we make a mistake, we can kind of loosen it up and readjust it. So we just want to tack it onto the motor tube when you insert it through the fin slots of the airframe.
If anyone's looking at the slide that's up, maybe ignore the image of the fin and the tube of epoxy. That's pretty incorrect. Follow what Mark and Frank are doing.
That single tube of epoxy, yeah.
Yeah.
And don't forget to mix
Yeah,
your
don't put the
epoxy.
single. Yeah. That was me, wasn't it? Yeah.
Don't forget to mix your epoxy, 1-to-1 ratio. And then use your craft stick to scoop it up and spread it on the tang end of the fin.
Mark, is that your photo?
Yeah, it is.
Okay, so ignore Mark's photo. Just do what Mark is doing.
Do what
not what
I'm
he's showing.
doing, but don't do what I drew.
Yeah.
Yeah.
Don't do what he did.
It's just an example, right?
I didn't do that. That was just a demo. I didn't want to mix a pot to take the picture. So.
And doing this in a timely fashion because you don't want the glue to set up too much. So let's butter the end of it and stick it through the fin slots and make sure you touch the motor tube with the tang.
Right.
Yes.
You want to get all 4 fins on within 5 minutes before that first fin sets.
Right.
Aaron, great use of your tile floor.
Ashley.
Did he use it?
Aaron Ashley. He's demoing.
Yeah.
Right.
Great example, though.
Right. I think we had to do that at some rocket build, didn't we, for somebody? Anyways, make sure when you put your fins in that the root, the forward root and the rear root touches the airframe. So there's not such a big gap. There might be a little small gap in there, but make sure it's not make sure it's straight. Everything's up against the airframe. Check and double check. Once you have your tanks all epoxied and in the rocket, and you have your rocket on the fin guide, constantly observe the alignment of the fins and the line on the fin guide. Because your fin could pull away from the body and you got to push it back in. Once you push it back in, it'll probably be misaligned. So you have to straighten that fin out, check the other 3 fins. You have
Then
to
use the tape to hold it in place if it doesn't want to stay in place.
Right. And if you have a slightly warped fin, no big deal. Just as long as it's not a right angle fin. Maria, she's done. Awesome. Let's hurry, hurry. A lot of people's cameras off.
We're coming back at 1 p.m.
Yeah.
1 p.m. Yeah.
How you doing, D'Angelo? Okay.
Anthony, are you here? Because we see just
Yes.
Okay.
I'm on the floor since
Okay.
I don't have enough room on my desk.
Okay. Just making sure.
How's it going, Willie?
Marlon, how you doing? All right. We gotta let that glue set up for about a good 10, 15 minutes because you'll be handling it here in 15 minutes. We gotta make sure the fins get set up real good. As a reminder, make sure your fins, your root of your fins, your forward and back roots are up against your airframe. So they're not lagging, not sticking out at all. Make sure they're flush up against the airframe.
Make sure to push them in all the way.
Yep.
They might not be touching the motor mount tube in the middle if they're not pushed in all the way. And then keep in mind for your competition rocket, there's tools and jigs you can buy that'll align your fins. You could probably even 3D print something. for the workshop, this is the simplest, easiest solution.
Okay, okay, Nikki's done, Maria's done. As soon as you're done and you think you're happy with your alignment, leave your rocket cure for a few minutes here and give us an R.
Andrea, do you have everything set?
Andrea, you should still have your rocket down on the floor on the fin guide, but because I don't want anything to move as you're twisting it until that sets up, please.
Andrea, do you have epoxy on your fins, or are you just getting your tape ready?
No, they're done.
Oh, okay. Yeah, I'd keep them on the fin guide and just make sure they stay in place. They have a tendency to swim around.
They move mystically.
It will move. It'll come away from the mount.
And I'm going to go back to what I asked in the beginning of the workshop. Please do not work ahead, even though you may know what you're doing next step, just keeping us all at the same pace. And so that our team can review each step. Since we're not in person, we really need you to follow along with us.
Is Taylor with us anymore? Or is that just another camera?
I think she's on her phone for the audio.
Yeah, okay. Nice, Aaron. That's pretty cool.
If you have put your fins in, installed them, you can, I think we're doing inners, never mind. Are we ready to go to the next page yet?
What's the next page?
Well, I don't see like people putting tape on to secure the fins in place. So do we still want to cover that?
I think we did. I don't know if any of them need them or not.
Yeah, we mentioned them several times.
I've got tape on 2 of my fins. If you can see my screen. The other 2
use tape.
Line up nice, but
Part of that reason, yeah, is you don't want that upper part kind of falling out. You want to keep it close to the airframe.
and it'll take a good 10-15 minutes for that epoxy to set.
Yeah, make sure your fins, your root fins are up against the airframe, the front and the lower part.
So it's not super glue. It's not instant tack. It'll take a while.
Right.
And so can I see, what is the next slide?
Inner fillets.
But if they wanted to start getting their tape ready and just putting it aside, not on the fins, but just on the side of their workspace, they could do that. Just make these pieces of tape.
Well, that's also the step that they do while they're waiting for the inner fillet to dry. Right?
Right.
I'm scared to touch it. I'm scared they're not dry. I don't want to move it.
I know, eh? Tyler, are you happy with that?
Yeah, I'm just taping it now.
God, I can't see your past your avatar. How's it going?
I'm doing good. I just, I had it on a table and I moved over to put it on the ground and get a
Gotcha.
better bird's eye view of it.
Is that Seattle?
Yes.
My wife's tribe is just outside of Seattle.
Who's your wife?
She's Squam.
Squam?
Never heard of it. Sounds made up.
You just picked her up. Or you picked him up.
Does everybody have their tape ready to go for the next step? So you'll have sections about 6 to 8 inches long. Yep,
Hold on.
exactly, Tyler. You're gonna need
Hold on.
about, is it 8 of them if I'm not mistaken?
Actually, you're gonna need tape to cover your motor tube and your internal air frame tube so you don't get any epoxy on those parts when you're doing your internal fillets. And if Mark would show you on this technique is done.
I don't want to touch it. It's not
I
tacked
know.
yet.
I know.
All right, well, it's tacked.
Now, the object of this is not to lay the rocket on the table. You have to lay the rocket on the edge of the table with the fins floating in the air, because otherwise your fins are gonna spread if you put your fins on the table. So put your fins off the table. If you have to put something in between the rocket so it doesn't roll, or put a long piece of tape over the airframe onto the table to keep it steady so it doesn't roll on you, you can do that.
So the
And-
tape that Frank was mentioning is.
And you have to put tape so you don't get no epoxy on the outside part of the motor tube, because your aft motor ring's got to go on there after we have everything glued up, so you don't want no trouble putting it on. So put some tape over the motor mount tube, just like maybe a 1/4 inch to a 1/2 inch where the fin comes to.
I think Willie's doing it right.
Yeah, wherever the fin comes to, where the tang of the fin hits the motor tube, just put tape in that far. So you're acting it as a like a tablecloth, which you're not getting glue on that part. And put tape on the internal part of the airframe also, so you don't get no glue on the internal part of the airframe.
So you're just protecting that area from over epoxy. We don't want epoxy on the area, so we're just going to put tape there to protect that.
Right.
Because
You
you'll
can
never get your aft ring on.
So you put it on the middle tube, and then you put it also on the outer tube.
Right. You can put short little pieces on each section you work on,
Yeah.
and peel it off when you're done, when you rotate your rocket to put more epoxy on the next fin. What we're going to do is mix some epoxy, and we're going to put epoxy
Inside.
on the fin between the motor tube and the tang of the fin. And Mark will show you that. And I think I have yeah, it's not a very good picture because I have the tube in there. You can't really see it too good. Nah. I have a cutaway of the same rocket here. And I have the aft closure in, but you can see where the tang is epoxy to the motor tube.
Danielle, can you spotlight Frank's camera? It might be easier to see for everyone.
I am spotlighting Frank's camera.
Oh, sorry, that's just the view that I have.
That's all you get. I forgot to put the dye on in there like I did on these fillets.
So there's the finished tape on both rings, or both airframes, or both
There you go.
tubes. Sorry.
So you want to mix some epoxy, 1-to-1 ratio.
Sorry, for the motor mount too, we cover the tape inside and outside, right? Or just the outside?
Just the outside.
Okay.
Because we're gonna put the epoxy in between these 2 layers of tape.
Okay.
Ain't a bad idea to put it
I
inside
mean,
too.
if you don't
but-
trust yourself, you're gonna
Yeah.
accidentally put epoxy in there, then maybe.
Yeah, if you find that you put
Never happened.
epoxy.
If you find you got
that put-
epoxy everywhere, then maybe you put tape on the inside as well.
But if you find you have epoxy in a spot it's not supposed to be there, just take your alcohol and the alcohol wipe and just wipe it right away.
And I just want to remind everyone at this point, be very, very gentle with your fins. Try not to bump them. Try to make sure that they stayed aligned. So that's why the tape is beneficial if you taped them when they were aligned so that they don't displace.
Right. Make sure you hang your fins over the table so the fins aren't resting on the table.
Totally not aligned.
And for those of you a little bit concerned about that motor mount tubing getting something inside and asking if you can tape the inside, I have even just taken like 2 inches and put it over the top of the tube. Instead of going around on the inside, I've just put it over the top.
Like so.
Yep, Mark's showing you.
And make a
I find
fillet.
that method to be just a little bit easier than trying to go around the inside.
And once you get your nice.
And alignment's off.
And once you get your epoxy mixed up, make a fillet like shown in 13-7. Make a fillet between your tang on your fin to your motor mount tube, the whole length. So that means you may have to use your stick possibly to get in there that far, your dowel, or put 2 craft sticks together, whatever makes you more comfortable. And put the epoxy on. You could have your fins in a 45-degree angle like shown like this. So you put your epoxy on 2 fins at one time and keep it there for a couple minutes till the epoxy gets tacky, and then rotate your fin and do the other 2 same way. And don't forget to hang your rocket into open air. Do not lay your fins on the table.
I'm going to show.
So as you're doing this, remember in total, you'll have 8 fillets. You have to do each side of the fin.
1, 2. So yeah, so Frank said do 2 at a time. So do these 2 here, 1 and 2, and then rotate, do 1, 2, rotate, 1, 2.
For reference, as you have your rocket laying horizontal off the side of the table, you're doing the 2 top fins. So
Yeah.
gravity holds the fillet into place.
So it's positioned 1, 2.
Right, and I guarantee it, by the time you get your second set of fins, your epoxy will probably be setting up the one you're trying to use. So just mix enough epoxy for those 2 fillets you're going to make.
It's hard to.
And just a reminder, if you're not, this is probably a good time to be wearing gloves.
And you may want to, before you start tacking the first one in, the epoxy, you may just want to put your rocket back on your template and make sure your fins are still aligned. Because you've been moving it around and everything, just might want to make sure you're good to go. And if they've moved it all, throw on a couple pieces of tape to try and hold them in place.
And keep in mind, you're probably gonna have to mix multiple pots of epoxy. So you're not gonna be able to get all 8 fillets with one mix. So mix a little bit, maybe do 2 or 4 fillets and then throw that one aside, mix a new pot. Because it's gonna be 5-10 minutes in between each one. Epoxy everywhere. This is garbage.
And I see a lot of people are like holding their rocket for this part. But again, it is easier if you
Be like this.
lay it like Mark is showing now and lay it so that the fins are hanging off the table, like Frank has said a couple times.
Like that.
Yep, and then you don't have to hold it and the epoxy won't drip. It'll stay in place.
So I'm holding it because I'm trying to show you guys, and it's very difficult for me to put the epoxy the way I'm holding it.
Right, if you secure your rocket to the table with it hanging over, you got 2 hands to work with then. One to hold what you gotta mix and the other one to apply the epoxy and possibly hold your rocket, but
So
do not touch the fins.
it looks like Willie has his standing up. Andrea has hers standing up.
So don't do it like I'm showing you. If that's what you guys are doing, you're trying to follow me, I'm only doing that because the camera is here. I need it to be pointed that way.
Need to hang your rocket on the edge of the
If I do
table.
it this way, like you're supposed to be doing it, you can't see what I'm doing.
There's another view from Frank so you guys can see how the fins are not touching the table. They're hanging off, and he's going to put a piece of tape over the airframe so that it stays in place while he epoxies the top 2 inner fin fillets.
Nothing goes right when you're on camera.
Whatever could you mean?
Right, yeah, this is my first time building one on camera, so I'm a little nervous.
Just like that, just secure your rocket just like that on the table, and you can start working on the back end with your epoxy in one hand and stick in the other, and apply the epoxy and make your fillet between your tang and your motor mount too. The whole length of that tang. Because if you try and put the epoxy on when it's standing up, all that glue is going to run off that tang and run towards the middle of your motor mount ring. And that's what we do not want.
Frank's got a great close-up if you're not looking at your camera right now. Andrea's got it. She's working on it really nicely. Rocket horizontally, craft stick all the way up the slot along the fin tang root tab.
Nice job. That's the way.
And if you're keeping pace with timing, you should be almost heading on to your second set, your second side that you're gonna be filling in those fillets with.
Willie, how you doing? Oh, you're just putting it on the table now. Okay. Let's everybody keep up so we can keep going here. Oh, Willie, you got to tape yours yet? Okay.
I already finished. I just removed the tape.
Oh, you got to keep the tape on, bud.
Okay.
Because we're going to do all the other 3 sides.
I think he's saying he already did all 4 sides.
You did all sides.
Really?
Yeah, that seemed really quick.
Okay, well, make sure your epoxy isn't running all over the place either. Kind of look at it like you were. Okay, excellent. I didn't know you were done. How about did you give us an R? Well, you show off.
Just to give you guys a kind of an idea, this segment goes till 10 minutes till. So that's when we have to have everybody done, so that we have about 10 more minutes, giving you about 5 minutes on each side.
If you have any epoxy, on the internal side of the airframe or the external side of the motor tube, you can wipe it off with some alcohol wipes.
And I'm going to make an example of Mark at this particular moment. Everyone should be wearing gloves at this point. I realize it's awkward because you don't wear gloves when working with fine detailed things, but PPE is there for a reason.
I'll see what I can do.
Blaming you, Mark.
I didn't get it. I didn't get it in my kit, so nobody shipped me the gloves. So
don't you have those at home for general purpose at all? No.
No.
Okay.
Maybe.
Andrea, are you rotating your rocket around so you can do the next set like that?
Not sure what you mean.
As you,
Both sides of the fins.
okay, you're not trying to go ahead and put a fillet upside down as you can rotate the rocket around and do the next set.
Oh yeah, I already rotated it.
Okay.
How about one glove, Kev? Is that good enough for you? My epoxy hand.
What are you, Michael Jackson?
Yeah.
Just another reminder that if you do have all 4 sides, so all 8 fillets done, you want to keep your rocket flat on the table so that the epoxy doesn't run. So lift it up and keep looking at it. Just keep it flat on the table. You can rotate it slowly so that everything sits nicely, but just don't lift it up.
Meanwhile, while you're watching this dry, you could tear off a couple of 12-inch pieces of tape, and we're going to need 8 of those to mark off the external fillets. And you could hang those on the table if you haven't done it already. Tyler, how you doing? Looks like you're doing a little epoxy.
Yeah, I don't know if I have enough, but I think it's okay.
It just has a make a little fillet out between the tab and the motor mount tube. What do you mean you don't have enough epoxy, or enough epoxy applied to the area?
Epoxy applied to the area.
Okay.
Yeah.
Yes, yeah.
If you're not there yet, you should be just about moving to your third side.
Right on. Thanks, Danielle. I'm just on my third side.
Like I said, if you have all your sides done, let's take off some tape 12 inches long, and you'll need about 8 of them. Hang them on the side of the table, hang them on your pants, hang them on your shirt so they're available.
You mean 16?
Yeah. I don't like this tape.
I can barely see it.
I know. Stand by.
All right. I hope that's that.
We got 3 minutes left there, Christine.
I think Danielle was our timekeeper.
We have like 3 or 4 minutes.
minutes. Yeah.
You get it taped up, Frank? You need me to, do you mind?
Yeah, go ahead. Yeah, I'm good.
Wow, look at that tape.
I don't use that. I only use painter tape for paint.
That's a big piece of tape.
Frank, you're working ahead, so I'm not going to spotlight you. You're working ahead, Frank, so I'm not spotlighting you. Okay?
Okay, that's all right.
Don't follow Frank. We're not there yet.
Nope.
Do what
I'm a
Frank
messy-
says, not what he does.
I'm a messy painter. That's why it's wide.
He's trying to get prepared for the next step. It takes a couple minutes. So I'm all set up here. I got all my inner fillets done. I'm letting it set for a good 5 minutes, and then I'm gonna pull the tape off the back end.
There you go.
So the problem is if you let the tape sit too long, the epoxy will actually, you'll end up epoxying the tape in place. How's everyone looking? Aaron? I just see my thing's not set up right.
If you haven't moved on to the fourth side, you should be on that by now. You'll have a few minutes as we go through stability that you can like listen and continue with your fillets, but we're about to move on, so just be prepared.
Oh, there's a stability slide in there, right?
Yes.
Yes, there is. Yep. Aaron's up for
Um,
the next 10 minutes.
We'll pull that tape. So yeah, because Frank worked ahead, he's setting up for the next step. So once you guys are done, I know you're not done, maybe you still might be working on it. And then once you finish with, when Aaron's working on his stability slide, you'll end up pulling that tape off the back end. Trying not to get epoxy anywhere.
That's why you should still have your gloves on at this point, so you can take it
Yes,
off and not
sorry.
get epoxy on you.
So don't do what I'm doing. Again.
And you'll also want to make sure that you do take off the tape before it hardens, just in case there was any epoxy on
Yeah.
it. You don't want the tape to stick.
That's what we were just saying. You could end up, if you leave it for too long, you'll end up epoxying your tape on. So try and remove the tape carefully if you've got all the fillets in there.
All right, we're gonna head on. Keep working if you need to, but otherwise just tune in, listen to Aaron as he talks about stability, okay?
So you guys should be somewhat familiar with stability. Handbook page 26 is the same picture that's displaying right now. But I was saying before with the motor that if the thrust to weight ratio is not high enough, that it won't get off the pad. That's one kind of version of performance. The other is once it's off the pad at sufficient speed, I'm just going to use this. This is just my top part. Actually, can anyone tell me what center of gravity is? I'm sure you guys have seen it in your proposal and PDRs so far. If anyone has a free hand, if not, I know you guys are trying to do stuff. So. Anyone on what CG is?
I'm gonna say center of gravity is where the mass is most stable.
Yeah, like where it's at. If I had my fins on here, it's where I could balance the rocket. Like there, that would be my CG. But yeah, and then center of pressure, I'll just go ahead and fill that in. That's where your aerodynamic forces act. So the fins are primarily influence the center of pressure. And in that figure 6.1 or figure 7.1 on the slide and in the handbook, they're marked there, and then we generally draw them on the rocket, that little CP symbol. I kind of drew mine in pencil there. That's my CP symbol based on my rock sim. So I just measured it and marked it there. And then same thing for the CG. You can mark that, or I generally mark it with one of the rail buttons, but that's good to know on the launch pad. And And stability margin, there's a nice equation in the handbook, equation 7.1, but it's basically you take the inch markings of those and subtract them and then divide it by your body tube diameter. And Roxen gives that to you, but it should be between 1 and 2, ideally between 1.5 and 2. But I'll just review what happens if they're not that. So when the rocket's going up and you have a stability margin of less than 1, it'll just go all over the place. Like it won't even go up. It could like go all the way around like that. Something you don't want. If it's over 2 or over 3, we call that overstable. If there's wind, like a windy day, it'll push the rocket this way, but then the rocket will keep going that way. If you have the proper stability between 1 and 2, if the wind pushes it that way, the rocket will want to correct itself to go like that, so they'll continue going straight up. So overstable, it'll fly, but it could go like horizontally, which is not ideal either. So ideally between 1.5 and 2. If it ends up being like 1.05, that's pretty pushing it. Probably aim for at least 1.5 and below 2, or low 2s is good as well. And then when we actually get to the launch pad, the reason I mark them on my actual rocket, I mark where the CP is calculated. You can't really check that in real life, but the CG, that's something you need to check on the launch pad. So say your Roxen says your CG is at 14 inches from the bottom, but then you go and actually, once you have it all loaded, your motor in, you balance it on the launch pad, it's like, oh, it's like 17 inches from the bottom. That's not good. So you may be unstable or overstable. So it's good to have some way to correct the Roxen based on what you actually weigh, so you can get the most accurate idea of your stability. And that's about it for stability. I mean, handbook just goes over what each of those are and what'll happen if it's unstable and overstable. But that's basically it.
Just to clarify, you wouldn't check that on the launch pad. You'd want to check that when you're prepping your rocket long before you get to the launch pad.
Oh, yes. Launch.
Not to confuse anybody.
Yeah, launch site.
Perfect.
Okay, are we doing the outer fin installation next?
Yes.
Okay, if you have, yes,
So everybody should have those pieces of tape ready to go for this step.
okay, see, you have your 12-inch pieces of tape hanging on the table. Put them on your rocket as shown right here, on your fin and on the airframe, and allow at least 3/16 to 1/4 of an inch between the fin and the airframe, as you can see right here. I have blue tape to show you that. And one important thing, lay your rocket level on the table, and don't forget, hang your rocket over the edge so your fins are in the air on the end of the table, as shown in the figure. What is that, 13-8 for your fillets and tape?
13-18.
Okay.
Or 13-19.
Let's go to 20. As you can see right here, I have a little piece of, I have a piece of tape right here, masking tape. I just showed it for a different color. It acts as a dam, so your when you lay your fillet on here, as Mark is doing, I can't see you, Mark.
Okay, are you showing Frank or is Mark showing?
I don't know. Hold on.
Kind of both doing. We're both have them. Whatever you want.
Yeah,
He's talking, so.
I use this masking tape here for a dam so your epoxy does not run off the end of your rocket. I put one in the back and I put one in the front right here so it doesn't run alongside of the airframe. Same thing on the other side. You can do 2 fins at one time and you should end up with a fillet that kind of resembles that. And as soon as you get a nice bead on there, use
We're
your,
not to epoxy yet. We're just putting the tape on.
right, just showing an example.
That's a nice fillet. Who did that? I think that was me. Is that mine? Yeah.
No, I actually put red dye in the epoxy here so you can see it better.
So you guys all done your tape step? We want to observe and before we proceed to epoxy, I think we want to see your tape setup.
Yep. I agree.
Are we gonna do all the way around, Frank, or do one at a time?
We'll do 2 at a time right now. I think it'd be better because you put too many pieces of tape on there, the other side will stick to the next one and it'll be pulling off.
Yeah.
Let's see. Andrea looks good. Is it Andrea or Andrea?
Oh, it's either.
No, it's not.
Either.
Yeah, it
Whatever
is.
your accent is.
Okay. I can't see any rockets. I see they're busy.
Yeah.
And please keep in mind as you're putting the tape on, the dam up spots where epoxy could seep through, especially through the fins where the root is not quite close to the airframe. It might leak through there, so put some tape on the back side of that too. Anywhere you think epoxy is going to seep or run, dam it up, secure it, block it, plug it.
Unless you use filler. If you use filler, then you won't have that issue.
Let's
But
not
we
confuse
don't
them with things
have
we don't
filler.
have.
Correct.
Not part of this rocket workshop.
So,
No.
yeah, not for you guys, but guess who's over here cheating?
That's right. And once you get those 2 fins taped off, you can mix your epoxy and make sure your dams are in set and your holes are plugged or they're going to seep through the fins, front and the back.
How's it looking, Nikki? Can you hold it closer to the camera? Okay, you got the outside, but you also have to put 2 strips through the inside part as well. Or is it that I just can't see it against the white airframe?
Yeah, she's got it on there. I see it.
Okay, yeah.
White tape.
That cream colored tape on a white airframe via a web camera makes it really hard to see.
I'm not clear on the dams. Can you, or where's that supposed to go? Just above the slots?
At the forward part of the fin, I can't see my camera here. Hold on.
You're trying to fill in this gap, Scott. See the gap on this side? You're just trying to dam that on the other side. You would dam it on both eventually. I just only have 1 tape so far.
Yeah, I got one here on the forward part of the fin, and I got some on the back right here.
Such
I have
that
it-
when,
And I
such
have it
that
all
when
the
you-
way, I have
Go
it
ahead,
all the way
Frank.
around the bottom, like that.
such that when you put epoxy in here, Scott, it's not gonna leak out the back side of it.
Oh, so we need it on one side of each fin.
Yeah,
Yep.
just on the back side of each fin.
Don't forget to put your gloves on. I know it's hard to grab the tape and put the tape on it, and your gloves are going to stick to the tape more than it does to your skin. Very good, Mark.
Thanks, Kev. I was getting Kev's approval.
Thank you, Kevin. Mark, keep your gloves on. You are
Thanks,
a role
Kev.
model.
Your glove, keep your glove on,
I only
Mark.
have one glove, so I just one-handing my epoxy now.
Just mix enough epoxy to make a fillet as shown, like I did before. Like that. Nice smooth fillet you're gonna make. Fill in that gap that you have exposed between the two pieces of tape. Use your craft stick and swipe it nice and smooth. And then as soon as you get done, you're satisfied with it.
Hold on. Sorry.
Hold on.
Can we check tape, please? Because there's some people holding up tape, so I don't want to go to epoxy yet until we know that the tape is okay. So Anthony's asking for tape confirmation.
I'm looking at Anthony's and the resolution's kind of low. I think it's all in the right spot. So I'm going to rely on Anthony to tell me if you got it like the illustration and figure.
Anthony, I can see it pretty good. Show me what you got there. Okay, and you got to put some on the fins too. Same distance away.
And Willie's using Scotch tape, so it's even harder to see.
Oh, does he have it on the fins? Oh yeah, he does.
It looks like Scott's got it.
And then the dams on backsides.
Backside, yep. Here's a life lesson for everyone doing this. If you ever look at anyone who professionally silicones a bathtub or a wash basin or a backsplash around the sink, they will use this exact same technique. So even if you never build a rocket again, at least you know how to tile and grout and silicone your kitchen.
And building on that, Kevin, is when they are siliconing their bathtub or around the kitchen sink, that once they lay that epoxy down or that caulk down, it is a one single movement from, you know, the beginning to the end. It's not a dabbing process. It's not a let me go halfway and then let me go back over it and then let me go back over it again. Do one smooth drag across the fillet, so then you'll get that nice concave, right, fillet that you're looking for, like Frank showed earlier. So that's the goal of what you want it to look like. And if you follow that step of going one single slide with your craft stick, you should get that look. And not pressing too hard where you move all of the epoxy out of the area that is not taped. So you want to get that nice adherence between those two, you know, that right angle.
So not the squeegee, but kind of form it in.
Yeah,
He was looking for confirmation. He's holding up his tape.
What do you got there, Tyler?
I think it's just excess tape at the end.
Okay, a little bit. Okay, and like Christine said, and Kevin, all you're doing is smoothing it out. Once you let the epoxy sit there, it'll actually puddle and pool in that crevice.
All right, so let's go from step one on this screen and walk through. Now that we're here and everyone's here to epoxy, let's start with step one. So just get some epoxy ready.
Just mix enough epoxy for those two fillets. Don't mix too much. Mix enough for those two fillets.
And make sure to mix enough. Don't run out.
Right.
What were we using last time? 2 drops about the size of a quarter to measure out your 50-50?
Something like that, yeah.
It seemed like it covered a fillet good. It seemed like that covered the 2 fillets for each side really well.
Yeah, you could set your epoxy bottle down on the paper plate and draw a little circle around it, and that's a good size.
That was pretty good, Danielle.
She's not just the timekeeper. She knows what she's doing.
She may have
level
built a
130
rocket once. She may have built a rocket once.
Got to put this physics degree to good use, you know?
So where's Mark? Is Mark got his gloves on and doing the pour?
Yeah, I'm working ahead here, apparently. I mixed my pot. I didn't want to waste it, so I just went ahead and applied it.
Okay.
Mark, stay on course. Don't get ahead.
I'm sorry, Mark. I mean the towel on you.
Everyone should be working on epoxying their first side, which should be facing upward. And if you're looking at the slide, figure 13-20 is where you're putting in your fillets.
Your fins should be at a 45-degree angle and your rocket level so your epoxy does not run off the rocket forward or aft.
Just like Mark's doing.
Exactly.
It's like everyone's gone.
Yeah, there's nobody on the screen.
I'd play some music like I get yelled at.
Yeah, can we get some Rocket Man or something? Some William Shatner version?
Oh, jeez.
The opening of Star Trek.
Rocket Man. All right, where are we? We're still doing the one side, right? We're still on the one side?
Correct. So if you
Yeah,
didn't
we're
make
still on the one
extra
side.
tape,
Tyler,
I was gonna just say, if you didn't make extra tape yet, you could just make your tape strips for the next side, but most people probably have their tape ready already.
Tyler, I'm just double checking on you. It does look like I'm getting short strokes from you. Are you doing one long stroke along that epoxy?
Yeah, I didn't have enough for the first stroke, so I got a second one.
Okay, just making
Yeah.
sure.
Okay.
Terrible fillet. Who's that? What is that? Right, sing it to us. Sing it for us.
You guys are teasing me.
How's everyone doing? Aaron looks good. He's ready. Scott?
Ready for the next set, I guess?
So we'll lift this tape first.
Yeah, always peel the tape off.
So, give it a good 5 minutes to set up, and then I'm gonna peel my tape now because it's been a while. I don't want my tape.
Yeah, as soon as you get done applying your epoxy, you should remove the tape immediately, but keep the dams up. Because if you let it set too long, you'll get the spider web effect. Sorry, I forgot to mention that. As soon as you get done applying the epoxy, take the tape off, but leave your dams up, or try and leave your dams up. If you destroy your dam, just pull it off and put another one on, just to keep the epoxy from running. It's kind of tough sometimes. Nice job, Andrea.
That was terrible. I ran out of epoxy. My second fillet's not the best.
So the object of putting a fillet on your fins is to make the fin strong, not only to the motor mount that you just epoxied it to, but also to the airframe. So you got 2-point contact of the fin to the rocket. And of course, when you paint it, it has a real nice smooth finish where you can't even see the transition between the fin and the airframe. And some people have very small fillets. Some people have very large fillets. It's just all in the user's discretion on how they want to make their fillets. But you always have to put a fillet on the external part of the airframe to the fin. Thank you.
All right, so everyone's pretty much done with their first side. Looks good, Willie. Aaron, you're good. Anthony, looks good.
How will they know when it's safe to rotate their rocket 180 degrees? Let's walk them through that.
I don't know what Frank's doing back there. So usually about maybe 5 minutes, 10 minutes after you've laid down that last epoxy, and then it's dry enough where you can turn it over. So after you've pulled your tape off, it's still going to be sticky, so don't touch it, but it's not going to be runny enough. It should be dry after about 10 minutes to be able to turn the rocket over and not worry about it.
Right.
So if you haven't already done so on the complete 180 side, you'll apply your tape again as shown, and I think I have it if my screen's up. Frank also has his screen. So I just finished epoxying this side. Those are my 2 fillets. And now I'm gonna do it again, do the whole same thing over again on the complete 180 degree side.
And you should end up with a nice fillet, or like this. It's a smaller side, but this one you can see better. Don't forget to remove the tape as soon as you get done making your fillet. Don't let it set up on the tape.
And a reminder that when you flip it over to the 180, you are going to be doing, you will still need to add a dam on this step. So step number 2 requires a dam. Step 3 and 4 will not. Step 2 does.
So you're doing the same screen that is on here, same process.
How's it going, Marlon? Everyone's just busy taping and epoxying away there. It's hard to tell where everyone's at.
It's okay, we have plenty of time. So As long as everyone's on their second side now, taping or epoxying, you're in good shape.
All right, I'm going for it. I'm going in. That is Rocket Man.
You're gonna get our video taken down from YouTube.
Yeah, that's a copyright infringement.
Right? We can't play this. You're killing it, Frank.
That was me singing.
I do believe the law is written, you get 20 seconds free. Or is it 6 seconds?
And then maybe when you finish your second side, you could put a 3 in the chat so we know you're ready to go on to your third side.
I ran out again.
D'Angelo, always cracking me up.
That is funny, isn't it?
I have some, it looks like some bumps from the, when we first put the fins in, the slots. So there's some epoxy that oozed out when we glued it to the motor mount.
That's fine. You can epoxy over top of it. You can also sand the epoxy when it's dry. So if there's any imperfections or you're not happy with your fillets. Yeah.
Okay.
How bad is it? More than 1/8 of an inch?
Is it a drip?
Yeah, it's like kind of just like when I put them in, then some of that epoxy that I had on the edge there.
Did you already
kinda
put a
squeezed out.
you already put a fillet over it already?
Yeah.
Oh, okay. Otherwise, you could have probably took your X-Acto knife and popped it off, but now you got the fillet over there. It's okay.
Okay.
Oh, God.
It is really snowing here in Kenosha, Wisconsin. We got lots of snow coming down.
You can keep it.
Right?
It's snowing pretty good here too.
It stopped snowing here. We're good. We got enough.
Mickey said it's hot here. Wow. Rub it in. We'll come visit you after COVID.
Actually, we have a little bit of snow on the mountaintops over here right now.
Hey, Nikki, is it warm by you or is it warm in that garage?
It's just warm out here.
Oh, okay.
I mean, everywhere. It must be like at least high 70s.
Yeah, okay.
At least. It's 2 degrees where I am, so got 68 more degrees than I do.
Yeah.
We're supposed to go down to 35 below wind chill.
Yeah.
Well,
Negative 11 wind chill right now.
Well, how you're dressed, Kevin, looks like it's 2 degrees where you're sitting.
I put my winter boots on over the break because I'm in the basement and it's pretty cold down here. So it's normally about 50, but with the cold weather, I think it's dropped a little.
Got a heater blowing on you?
No. And when we redid the furnace, they didn't put a vent in on this side of the basement. They took it out.
Okay, we can't complain anymore. Look at Taylor's weather.
Oh my goodness, Taylor, that's frigid.
And aren't you in the garage? It's gotta be ice
my.
cold out there.
Is it heated?
Oh,
There
goodness.
you go.
They're fine. They're used to that.
Yes.
Her garage is probably warmer than my basement.
Yeah.
Tyson, what's your weather like? Or Tyson, sorry, not Tyson.
Well, he's got the 70s going, I think.
Temperate. I think it's 70s. I think it's 70 at the lowest.
And you heard the description, right? Temperate.
You only need a weather forecaster just for the rain only.
Just remember, Mark and Frank, what was it, 3 years ago? 2 years ago?
3.
We were in Hawaii conducting one of these rocket workshops.
It was nice. I liked it. And then remember, I was in South Dakota all by myself. That was very cold. That was not Hawaii.
Yeah, we did. Well, it was cold when we did North Dakota when we were at UTTC as well.
That wasn't
It's
that bad.
cold.
It was nice in Wyoming.
Wyoming.
When were we in Wyoming?
I mean Montana. I'm sorry, Montana.
Okay. Yeah, Montana, we had a nice trip up there. Lakota Ray was cold, going out to the airfield to do the
Yeah,
actual launches.
Yeah, you guys, the way you were dressed.
So if your epoxy is set, remember to pull your tape.
And And you should be almost done with your second side. In just a minute here, we're going to move on to our third side. So if you still need to prep tape, get some tape prepped on your tables, your workspace.
And just remember, when you go to that third side, you're going to have to make sure that side 1 and 2 are dry enough that you'll be able to pull the dams off so that you'll be able to put your tape down and put on your fillets.
Frank and Mark, you want to walk them through side 3?
Well, Frank's watching a video or something.
I think Christine just mentioned that once you're done with side 3 and 4, you don't have to put any dams in the rest of those steps or that last step. Only the
So
fillet only.
So just repeat your tape without the dam. That's the only difference on 2 and 3 or 3 and 4.
James, Anthony, you guys have been really quiet.
Are they with
Got
us?
a thumbs up though. Yeah, we got a thumbs up from them.
Yeah, we
so.
got thumbs up. Yeah.
And Maria's been putting in the chat that they've been good.
Okay. Hard to grab that tape, isn't it? Andrea, hard to grab the tape. Those gloves on.
All right. So on the third side, once you guys get it taped up, just just do the same thing as before. Get your epoxy in those fillets.
Just make sure you don't have any epoxy inside the airframe or on your motor tube as you've been concentrating on your fillets, because that epoxy sneaks away sometimes.
Or you get it on your hand, you don't realize you're spreading it all over as you move the rocket around.
Right. Or when you go and stand up, the chair comes with you.
Willie, how are you doing? Okay. Yep. Do you have side 3 done, Willie? Yes.
You can put a 4 in the chat when you're ready to move on to the 4th side. And we'll just give people a couple more minutes to catch up. I see lots of people are ready, but we still have some time, so no rush. And like Mark and Frank keep reminding us, once you have your epoxy done, you can gently remove your tape so that the epoxy can settle in and become a nice smooth surface.
All right, 3rd side done. Is everyone good to go on the 3rd, 4th, Danielle?
Nope, we still just have a couple more people. So we still have about 2 minutes before we need to move on.
You know who's been
No rush.
quiet? That Aaron Ashley guy. Is he still with us?
He's there yet.
So if you're like me, your fillet should be improving the further you go. My first side is pretty terrible. The last side is a lot better.
And I was gonna say too, I saw Anthony, looked like your gloves are getting sticky. I saw you like sticking them, so you can take some of the alcohol wipes that we gave you, and you can just kind of rub that to get some of the stickiness off, so it can be easier to do your last set of fillets.
Or you just put the other pair on, because you're almost we're almost done with the epoxy. A couple more applications, light ones, and we're done with the epoxy.
Yeah, less care. Definitely just use some alcohol wipes then, and that'll take care of it. All right, you guys probably got the deal now, but Mark and Frank, are you gonna walk you through step or side 4? And if you don't want to do exactly what Mark's doing, you still want your fins to hang off the edge of the table just to be safe.
All right.
Mark's quickly becoming the example whipping boy.
Yeah, I gotta show you guys what not to do. You know, you need an example of that as well.
Roll, Mark.
What was that, Aaron?
Oh, Mark can't steal my roll.
You mean forget the rail buttons?
Ooh.
All right, so you should be taping up your 4th side. Again, you don't need a dam anymore. So you're just worried about you're worried about the tape on the airframe and on the fins. And Andrew is still using that great tactic of taping the airframe to the table to hold it in place and hold it steady.
And Scott, how did your damaged fin go? Are you managed to work around that?
Yeah.
Okay.
But I will have some of that slot kind of exposed.
Yeah, that's fine. I mean, we could also patch it up later with some, dare I say, filler, or be jumped on by the team here, but.
I was just going to suggest trying to cut a piece of plywood to match it, and then maybe feathering it over with some Bondo.
Yeah, we can fix it up later, Scott. I'll, yeah, at the school or with Mike.
Okay.
That gets to be a creative conversation for another day.
And if you're taped up, mix your last batch of epoxy. Make your fillets.
And as a reminder, make sure there's no epoxy on the aft end inside your airframe or on the motor tube. If there is, wipe it with some alcohol, or if it's already cured, take your X-Acto knife and just kind of peel it off.
It looks like, Willie, you're done with all 4 sides. Awesome. If you didn't finish loading in your motor from Roxim before, now would be a good time to do that, because we're gonna move into Roxim again at 10, whatever time you're in.
And just a reminder, Willie, because I see you almost knocked your fins, those still aren't completely secure and dry. So make sure that you're not jostling that around, because you don't want to move your pins, okay?
in real life, as you're building your competition rocket, you generally do your tab to your motor mount adhesion. Usually takes like 1 day or several hours for it to cure before you start doing your external fins, because you want to use a stronger epoxy with for a bigger rocket, and maybe you'd want to put fiberglass tethering on the joint between the tab and the motor mount tube. So just a reminder, don't try and build a rocket
Yeah,
in 1
don't-
day.
Yeah, don't build your competition rocket at the same time that we build the workshop rocket.
Exactly. Hey Bob, what's Margaret doing?
Catching up on the news.
Oh.
Oh, Jesus.
Okay, and just a couple more minutes for you to finish your outer fin fillets. If you are done, you can get your rock sim pulled up again. If you did not finish loading your motor in, I put the video again in the chat if you got, lost or confused along the way. So we're gonna start rock sim in 2 minutes.
Yeah, Andrea, if you keep that epoxy will pool and straighten out if you got enough on there. It should level right out by itself.
The more you keep working it, the longer it takes to set.
if you're waiting, as Danielle said before, make sure you have your rock sim pulled up and ready to go. Because Aaron, it is 2:50.
You want me to go ahead and start in the rock sim?
Yep, go ahead, take it away.
Yeah. Okay, so we got our rock sim window back up. We had left off last time with about to do a simulation, and right now you can kind of see the margin over here. Stability margin is a bit overstable. We can change that later. Yeah, later this afternoon I'm going to talk about rail buttons, but James says our motor is, what is the rest of that comment? James, can you ask that? I didn't see that. I don't have the actual chat up.
Is that in the simulation or
Yeah,
in real life?
in the simulation, the motor is like sticking out the back. I guess you have to just move it.
But then it moves the whole thing.
Like the motor mount tube, like this one, motor mount tube.
The kind of grayish bit.
Yeah. I guess ours looks like yours now that we've
We moved it.
moved it.
The whole thing.
But the whole motor mount tube moves, yeah.
Gotta go motor mount and edit.
There's also an overhang when you load the motor. It allows you to overhang the motor.
Right.
Okay, how do we remove that then? That's probably what we have.
It's when you go to that motor loading. Again, it's all, there's so many features. I mean, getting off topic, but
I'm trying to click your program, Aaron. It ain't working.
Maybe that's share my other screen.
Under load engine?
Yeah.
Engine overhang. Okay, I see it. So we just set that to 0, right?
Yep.
That's our problem. Thank you.
Where was the engine overhang?
so in the motor loading feature, because it's like you can change the plug type, you can change the delay type, you can change the overhang, all in the engine load.
Yeah, that fixed it for us. Thank you very much.
I think it's trivial. It just moves the CG like half an inch further back or not even.
Yeah, it's kind of a goofy feature.
All right, this 2 screen thing's not working. I'm going to go down to 1 screen. Hopefully I can control everything there.
Half ring and then ring button.
Okay, so just to show where that was, let's see. Approximate full screen, just so I can have my toolbar. There. So up here, prepare for simulation, and then the motor overhang will be right here. So just a like 5-inch overhang, it pushes it back in this corner by that much. So 0 or 5 inches or wherever you want to that. So I was gonna just continue with moving a simulation. So we had clicked prepare for simulation up here. We chose our motor last time. We got the H219T. The delay is not plugged. It's 14. We'll just go with 14 now because that's the default. Flight events, you shouldn't change anything. That's max ejection delay. That's your motor injection. So keep it at that. You have no electronics, and it won't let you type anything here because it's motor delay. Don't change anything here. This is how the back-end calculation works. Make sure the launch guide is 6 feet or 72 inches. And launch, for ideal, you could put it 0. A lot of, I think Frank at Bong, we do like 5 degrees launch angles. I'll just do that for now. And then altitude, doesn't really matter that much, but the wind speed, well, we could try it with low wind speed, just to see how it turns out. Change that later. And this competition settings, you should not need to change anything there. So we can go to either launch or flight profile. Flight profile will be, we have to choose our well, it'll run the simulation and then we have to choose, oh no, this.
Can we back up and take a look at our fins?
What about the fins?
So your fins aren't touching your motor mount. So most people's won't be at this point. So how would they fix that?
Oh, good question.
The fin tab offset.
Tab offset, you said?
It's in the fin, yeah.
So main airframe tube, fin set, double click on that, and then
through the wall fin mount.
Oh yeah, TTW is through the wall fin mounts.
Just auto calculate fin depth.
Don't do that. You can always exit out, click don't save if you make a mistake, and then open it back up. And oh yeah, calculate the fin tab depth. Oh yeah, so it highlights it down here. Yeah, that's whoever brought that up. You can also add, like, we added a lot of epoxy, so I went ahead and put a mass object for epoxy. Like, my epoxy bottles are about 250 grams total, and assuming I use 1/5 of that supply, I put 50 grams here, and then we put them on each center ring and the fins, so I kind of, you can locate it wherever you think is the center of all those. So I just kind of put it there. But let's see, when you go back to launch or flight profile, it'll bring up that Roxanne does this like video display thing. This button also is the launch, and then this is 2D up there. You could just scrub through that. You can play it in real time too, but that's just the position, and then you could see a bunch of.
Aaron, can you slow down a bit, please? We're still adding the mass object for the epoxy.
Yes.
Sorry, thanks. How do we adjust the position, or where should we put that?
There's a location slide bar.
Yeah, where should we go?
When you have the
Where would be the best place to put it, by the motor?
You could. I mean, it's up to you on your competition rocket. You could put it on the CG.
Yeah, you could put it on the CG up here. You can see if you slide it around, it changes the CG as well.
What did you add? Like, 60 grams?
50 grams. Does that sound about right?
Yeah, sure.
Okay, thank you.
And then real quick question. Earlier, when you were setting us up, didn't you change things to be specific for Mark's rocket? Or is this supposed to match what our rocket is?
I have no idea what you guys have, so I have Mark's rocket because he was able to hear it. Do any of you know how long your motor tube was? I can update that if we want to make it match you guys' rockets.
And Aaron, do you want to go over when we're putting in our fins, the different materials they could be, and how we change materials.
Yeah.
Their motor tube was 11 inches.
Oh, 11 inches. Change that quick. And so I'm going to change your motor mount to 11 inches.
But the point is, you know, you never know what you get in your kit, so it's always good to measure it.
Yep. Measure and weigh.
Kits change over time.
When we were doing this a couple of weeks ago with the state teams from Wisconsin, we found that some of their fins weren't as long as the slots, right? So instead of fitting in that 5 inches, they might have been 4 and 15/16 or something of that nature. And so it's really important, as the guys were saying, making sure that you weigh and measure each component as you're putting it into RockSim, because that little bit, you know, it might be a little bit here and a little bit there, but that will end up affecting everything over the big picture. And little bits add up to lots, because your biggest enemy in rocketry is going to be that weight, right? And so you want to make sure that you are accurate, so you know what your weight is, so that when you go to put in that motor and you go to predict your apogee, you're able to match your motor and make sure you're going to go to the apogee that you predict.
Right. So to follow on Christine, for March 1st with your competition rocket, you should be absolute 100% certain. Don't just rely on the simulation weights. You should be 100% certain and have those components on hand and weigh them to do your motor selection.
And as Danielle pointed out, you know, this is a through the airframe fin and a certain design, but you may choose a different design of your fin, and so you have the ability to change that design and what it looks like.
And the span on the fin is, I hate to, you know, throw this in, it's 3.5, the fin span.
Yeah, the kit changed big time because the fins are a lot smaller on the newer.
Yeah, I told them about it. I wasn't,
a lot more aerodynamic.
the semi span, oh, you got a 3.5, it's cool. You got a 3.5 semi span. Yeah.
Semi span is from here to here, if you can
Yep.
select.
Yeah, you got it.
The root core length, I tried measuring it, my kit from 2 years ago, and it was 8.5. So I think that's still accurate. The tip core, that's this little one up here, appeared to be 1 inch on mine too. So I think that's still accurate, but material up here.
Yeah, it's no big deal on the length. It's the span that really counts. It changes the CG.
And with that, I just noticed that we're at 3:03 and we need to take a break. So is there anything else, Aaron, that you wanted to add? Otherwise, I'm going to let everybody scoot away for till 10 after, and it's a short break.
No, not for now. We have 2 more RockSim sessions.
Okay. All right, let's go ahead and break. Come back at 3:10.
And then more on simulating next time. So, yeah, I'm good.
Perfect. Thank you.
Jesus.
Is it okay if I go to breakout room to do the rock sim?
Erin, would you be able to help Anthony maybe for like 10 minutes, not much longer, because we do have to come back and build?
Yes, I can do that.
I need help with that too.
Was that Tyler?
Yeah.
Okay. Okay. I'm only gonna be able to put you in there for about 6 minutes, and then you're gonna have to come back at 3:10, okay? And so we'll be able to pick up later.
Or anytime next week. Or anytime, really. That's what we're here for.
All right, we are back. We're gonna move right back into build. You guys ready? You feel refreshed, refocused, re-energized? All right. Frank and Mark, ready to go?
Yes, I am. Okay, we're going to be installing the screw for the retaining nut that you have. Mark, you have the aft centering ring available. There it is. Does everybody have their nuts screwed into it along with their retention clips?
Not yet. Nope. We've got to walk them through that.
Let's put your screw and your retention clips into your T-nuts. The flange end is the forward part of it, and the clips go on the aft end of the motor mount ring.
Mark, you're muted too. I saw you were trying to talk.
The reason why we're putting these on right away is something to grip them when you dry fit them in your motor mount tube on the aft end. So once you get them on pretty secure, noting that you did not put any epoxy on the threads. Dry fit that aft motor mount ring the aft end of your rocket and see if you can slide it on in between the airframe and the motor mount tube to go inside. Like so. The motor tube should stick out a little further. I don't have mine glued in, but if you have any problems getting it inside, you might be burring the airframe or the motor mount tube. So you may have to sand either or, the airframe internal part or the motor mount tube or the ring itself on the inside and the outside. Doesn't have to be a super snug fit, but it has to be something where you can slide in without doing any kind of damage to the airframe or the motor tube.
And I'm just going to spotlight Frank's video real quick because I think Mark has different a different clip motor retention system. So let me spotlight Frank so you can see what your clip should be looking like right now as you're dry fitting the aft centering ring.
Here's the clips that you should have got with the kit, and this is one of my one that like Mark has. This is the other one.
Is it this piece?
Little Z clip?
Yep. Little Z clip, yep.
Do we need washers for this?
No, you do not.
put this down here. Now you see why it was important to keep that area clean of epoxy. You might have to sand it down a little bit if there's epoxy in there. Or...
And don't feel bad if it's hard to push in. If you got to take your thumbs and push down, push it in. But make sure you can get it back out because we're going to have to apply epoxy to get that in. This is just a fit.
Dry fit.
A dry fit, yep. And the motor tube should stick out maybe 1/8 of an inch to 1/16 of an inch past the aft motor mount ring. And the motor mount ring ought to sink in at least maybe 1/4 inch to 3/16 in. Because we're going to end up, when we get this all together and dry fitted properly, we're going to end up putting a fillet of epoxy on the motor tube. Oops, sorry, right here. And we're going to get a fillet of epoxy on this part right here.
Want to show one more time?
What's that, Daniel?
I just replaced the spotlight too. If you want to show them one more time what you were talking about for steps. That's not until what, step 5 though, right?
Correct. Now I'm on step 2, 3, 4, and 5. Actually, it's all together. Once you get your aft motor mount ring fitted in your aft end of your motor mount tube, we'll be applying epoxy between the centering ring and the motor mount tube right here. Also between the motor mount aft ring and the airframe. And your motor tube should be sticking out at least maybe 1/8 of an inch from your centering ring and a good 1/4 inch in on your airframe, approximately.
So to confirm though, we're not doing fillets on the outside yet because you still do need to apply epoxy. So you're going to take the centering ring off,
Yes.
motor mount tube, which is step 1C.
Right.
And then you'll mix up some epoxy.
So once you have a good fit and it goes on good, pull your aft ring up, pull your aft ring off, and apply. I have tape on mine, that's why it's hard to take off.
It's a little bit of work. It's a little snug.
Apply some epoxy on the inside internal airframe and on the motor tube inside, almost against the tabs of the fin.
And just remember not to get any epoxy on the inside of the motor mount tube.
Correct.
Only on the outside of the motor mount tube and the
Correct.
inside of
Well,
the
you can get, yeah, you can put it on the outside as long as it's wet and you're putting it on. It acts almost like a lubrication to put the ring on. But yeah, don't get it. Most important, do not get it on the inside of the motor tube. If you do, use your wipe to wipe it clean. And this is probably about one of the size motors you'll be using at the launch. It's right in there, nice and sweet.
A question about the 2 little brace things. Doesn't seem like the type of screws I was given fit with the different sizes.
It should be a machine screw. You have two different sizes. You should have a real small one. And you should have another screw like this. This one here, the bigger one,
Okay.
is an alternate for your rail buttons. This one, this smaller one here is for the retainer. It's pretty small.
It should have been in the same bag as the retainer.
Right. Should have been the same bag as the retainer or the T-nuts. You just dropped it on the floor and I can't find it. Oh, there it is.
Oh yeah, I just don't seem to have the correct screw for this part.
You don't?
No.
That's the bigger.
Oh, that's the bigger one. Do you have the T-nuts? Do you have these T-nuts or this the Z-nut or the Z clip?
Yeah, I have that attached.
Okay. Oh, you do?
Yeah, it's the other one, that one that I don't have the.
Yeah, that's just a standby one. You
Correct
should have
screw
two of those. You should have two of those Z-nuts, Z clips, right?
I think she has the two Z nuts. I think what she doesn't have is two screws. So she
Yeah.
doesn't have the second screw to put the Z nut in.
Exactly. What size is it? Just so I can go get one.
It's a number 4.
It's a number
Okay.
4
Machine screw.
Machine screw.
And if you get one, I think the ones they gave you are what, 3/4 of an inch? Half inch?
So I
They
think
seem
they're only-
short.
They're half inch.
Half inch?
Yeah.
If you have to get one, 3/4 of an inch might be a lot easier for you.
Yeah, for sure.
And it's okay if both of I got two of these Z washers that you're talking about, and this other one I thought would be for the guide or the.
Couldn't see what you were holding.
They gave you two types of screws for the rail buttons. They gave you a wood screw and they gave you a machine screw. And we're going to be using the wood screws anyways. The machine screws you can put in your junk drawer. But the one Angie was talking about was the small ones for the Z clip. Pretty small. And I put in these kind of clips here, just in case if your Z clips didn't work, you can use those in case your original retainer doesn't work, and you can just drill these right into the motor mount ring. And just clip the motor down if you have to, just in case part. So keep that with your rocket. So, did everybody get their ring to fit, a dry fit into their rocket yet?
Still sanding.
Are we having issues, problems, or are we still sanding, right? To get a real good sanding ability, especially on the inside, either sand your tube or take your. Oops, I can't see my camera here. Take your craft stick and a piece of sandpaper like this, and just go around in a circle like this on your motor mount ring several times. To get the outside of the ring, you can take your sandpaper on the table and scrape it like this, or whatever is best for you. And of course, always do the inside of your tube too, to get rid of the burrs, and the outside of the motor mount tube to get rid of the burrs on there too. Oops.
Okay, all I seen was Mark's screen, so sorry.
Mark, you're supposed to be demonstrating.
Oh, sorry. I was gonna say, I think that some of them have epoxy in there, and I was gonna say, if you have a knife, you can just, pick those pieces of epoxy, and that'll help you get in there as well, as opposed to sanding the epoxy down. So make sure there's no epoxy sticking to the side of the airframe or the motor mount tube. With the sanding, right, you just sand around the edges. It shouldn't be too much. You shouldn't have to take off too much. If your ring was manufactured correctly, if you got a defective ring from the manufacturer, then you might need to take off a lot more.
Mark,
So-
can you also demonstrate if you put a piece of sandpaper down on your table and you take your ring and how you would sand it? Okay, so that was the demonstration that Mark or that Frank had been showing you. That is another way to sand off a part of it if you need to.
So whatever way, if you need to take a lot, if you just take a little bit, you know, you can do it by hand, just holding one edge.
And
It
if you have
helps to taper it. So even just taking that little corner off gets it started into the tube, and then it'll slide the rest of the way.
And again, if you have to go on the inside, you can take your dowel or your craft stick and wrap your paper around it if you need it to be more round, or you can just sand it like Mark is showing you now. One of the things that you do want to remember that as you are going in and out, right? So preparing to epoxy, you want to make sure that those T-nuts, right? Those Z-clips are offset from the rail button mark. And so just think about that as we're kind of preparing to move along the steps, but that'll be important as you're fitting that in and out. Get used to seeing the clips offset from your rail button line.
Also, you don't want it lined up with your fins either, because if you screw the screws in far enough past the motor mount ring, they may hit the fins on the tabs too. So kind of make sure everything's kind of lined up where it's not hitting the fins or the rail guide button.
So you could think maybe, I know we've all marked our ring, right? It says A, it might be on the outside or the inside, depending which side you put your rings in. That letter should line up with your rail button line. If it does, and then everything else will line up properly.
Yep. Everybody having luck with their pre-fit?
Anthony's got it.
We do need to move on to the epoxying because we are supposed to be done with this segment in about 1 minute. So we'll want to make sure that we start that epoxying process. So if you have finished step 3, sorry, if you've, 2 and 3, please let us know. Put a 4, 5, put a 5 in. Let's put a 5 in if you're getting ready to do the 5th step. And if you're all done with everything, put an R.
Chris, can I proceed to epoxy, or should I wait for Frank to start talking about epoxy?
Nope, we need to move on. We're at 3:30. Feel
Are
free
you
to talk together.
Are we ready to epoxy?
Yes.
Okay, mix some epoxy, people. Enough to cover the internal surface of the airframe and the external surface of the motor mount tube. Don't forget 1-to-1 ratio.
Mark, don't forget to put on your glove.
Oh. Thank you.
Busted
And
again.
everybody else, make sure you have your gloves on.
I think you guys just pick on me now. Other people don't have their gloves either, but.
They should be. Everybody should have your gloves on. Thank you, Chison. I can see yours.
Oh,
Apply epoxy like about maybe a 1/4 inch in on the airframe, internal airframe, and apply epoxy all the way to the where the fin tabs are around the motor mount tube on the outside. Being careful not to get epoxy inside the motor tube.
Mark, your image is not centered. Thank you.
And also, while you put in your aft centering ring, remember to line it up properly, that it's not over a fin tab or the rail buttons. And as you apply epoxy and your ring gets pushed in, the epoxy actually lubricates your attempt to push it in, so it should go in pretty smooth if you had a good dry fit or a good dry tight fit. I can't see a single person doing it.
I know.
Well, they're working on it.
Webcams are set up to see video of people sitting in front of the computer. Aaron's got it.
Yep. Looks good, Aaron.
And once you get the part in, it's gonna have to sit up on top so the glue kind of, well, I don't know. What do you think, Kevin?
I think we had them invert it last time, so the epoxy pools to the ring.
Right. So we had the pointy end up.
Pointy end up.
Epoxy on both sides of the tubes, as you can see, before I enter the ring. Make sure the ring is lined up. So I'm going to use my rail button line to make sure my letter is on that rail button line.
Hey, Willie, who makes that epoxy?
I don't know. It's HFT. I don't know if that's supposed to mean anything.
I know those hazardous materials, people only put their, letters on them.
D'Angelo, do you have a question? You're squinting into the camera for a little bit there. Trying to read body language.
Okay, so you can see Mark right now. He has his down about 1/4 inch from the end of the airframe. And now he is.
The rail button line is offset.
Yep.
Now, once you have that completed, you are able to apply your fillet on the end of the aft centering ring. And again, as said before, you do want to make sure that you do not get epoxy into your motor mount. So if you need to, you feel like, oh man, I'm not going to be able to do that, go ahead and put a little bit of tape over the motor mount tube so that you don't put epoxy on it.
And to expound off step 5, I think a few weeks ago when we did this, we only did the outside of the centering ring to the airframe, and we missed the motor mount as well.
There was fillets on both sides.
On both sides. There was confusion about that a few weeks ago.
So if you're looking at figure 1321, it shows the 2 red arrows on the bottom show fillets going on the aft centering ring up against the motor mount tube, as well as the airframe, just like what Kevin said.
Yours looks good to me, Scott.
Yeah.
And the center is.
Yep.
Okay.
Yep, you're good.
So when we're doing the fillets, should we remove these clips and go the full length, or do we need to avoid that and only sort of go above and below? You can see the clips kind of go right to the edge where the fillet would be.
It'd probably be best to get them out of the way, but then you end, it's best to get them out of the way, but put the screws in the holes, bottom them out, and just put them in there so you don't get epoxy on there.
Okay.
Just gives you room. The clips are kind of in the way.
Is that what you're trying to show us, D'Angelo?
Yeah.
I have one T-nut situation. Uh-oh. Maria.
I usually just, yeah, I try to avoid that because I always worry, Aaron, that I'm going to put epoxy in that hole. So you don't need to go all the way around if you're worried about epoxying the threads on that hole or the T-nut.
All right, let's
Should the clip go above?
What's
Does the clip
Maria?
go above the body of the rocket?
What's Maria have?
Yeah, the clip's fine, Tyler.
Okay.
Maria has a T-nut situation.
She has them on the wrong side of the ring. Is epoxied. So you have the flange. The flange, is that what she's talking about? The flange is facing the wrong way.
Yeah, the T-nut's on the opposite side.
Oh, it fell out, she said.
Can you show us, Maria, on the up close James's video, just so we can see?
Yeah. So hopefully you guys all got the T-nuts goes on the inside of the centering ring. when
Yeah,
you
I guess
install
that
the
makes
center
sense.
ring.
So now my T-nuts started coming out.
On both, are both of them coming off, or just the one?
Both.
Because they're on the exterior side of the ring, correct?
Yeah, correct.
Yeah.
Okay. Is your epoxy set up?
Yep. Pretty much. I mean, it was tied to begin with. So.
Yeah. My thought is this: Frank put in those alternate clips, so I would use the alternate clips instead of those.
You could just drill right into the wooden ring with the screw.
Right.
From the outside.
This thing?
Yeah. Go to plan B.
Should we go in our break room and talk about it?
Kevin, do you want to maybe?
Yeah.
Okay. All right.
Thank you.
Let me. Yeah, no problem. Let me open that up. Just
Or, and also, Kevin, you know, another alternate besides the clip, you can even friction fit it with the clip too.
Yeah.
If you had to.
Could you put James on the break room because my camera doesn't work?
As soon as you are complete with this step, we need you to put an R in the chat. And the reason why is we are right now about 8 minutes behind, and we do want to try to get as close to being back on schedule as possible because we do want to be able to let you guys out on time too.
Tyler's set. Thank you, Tyler.
D'Angelo's set.
The R means that you also have done step 5 with the fillets.
Correct. Thank you, Danielle.
Well, if they do step 5, they're gonna have to keep the airframe pointy end down then.
Once we do the fillet, do we need to put the Z clips back in?
No, just hold on to the Z clips and put them in a safe spot.
Sucker's hot.
And you know what a safe spot would be? pop your nose cone off and put them in the payload section. Put your nose cone back on. And it's in there. Kind of like the rocket's glove compartment.
And if you don't feel comfortable doing that, you do have some like little Dixie cups that you could put them in as well. Marlon's done. So we have 3 of you done so far.
These guys.
Okay, if you have not done it already, let's apply some fillets around the aft end of the centering ring and the airframe, motor mount and airframe. Be careful not to get any epoxy in the side of the motor tube or in the threads of the T-nuts.
This is the most stressful part of the build, I find.
Yeah. Well, the next model is going to have a Estes / Aeropack type
Nice.
retainer on it.
I like that idea.
Also, you did have some alcohol wipes. So if an accident happens, you know, have that close at hand that you can wipe down the nut, the T-nut area or motor tube area if you have to hopefully remove the epoxy.
So we don't have to deal with the T-nuts with a different design then.
And or putting the T-nut on the wrong side.
Right. That means we're going to have to change the book.
Right, and the presentation.
Not changing, it's refining.
Oh man, whew, it's over. I didn't get any.
You
I
can
feel
breathe
so
now.
relieved. I feel so relieved when those final fillets are on there.
You can breathe now.
I can breathe. I didn't get it in the hole. I didn't get it in the motor mount.
Funny.
All right, so let's try and wrap this up in maybe a minute or 2.
Everybody looks good. How is everybody?
And anybody never heard this? Let's put our fillets on the motor mount tube on the external part and the airframe. You do not get any epoxy inside the motor mount tube.
Looks like Aaron's got it.
That's good, Aaron.
Willie, how's yours looking?
Jason, you good?
Yep.
Good job, bud.
All right.
Tyler, I see wrist action.
Yeah, I just took off the clips because they're getting in the way.
Excellent.
Yeah, so you don't need to go all the way. I leave it. I kind of skip over the area because I'm scared. I'm scared.
Right.
It's totally okay to go back at a later point when you've got more time and very gracefully work on
Clean
those
those
little
up.
points.
Yeah.
The rocket I built 2 weeks ago, there's a few spots I want to go over and touch up.
In 1 minute, we're going to go on to the next step. So if you are not done, get your listening ears on so you know what we're doing next as it's being explained. And with that, let's go ahead and go to the next slide.
All right, rail button installation. One of the most important parts of the rocket. The rail button installation is for your rocket so it has a straight glide off the rail. We're gonna work on the bottom button. I generally like to install it in the aft motor mount ring, so it has some kind of security to adhere to. And what I usually do is kind of gauge how deep your aft motor mount ring is and measure that depth and add 1/8 of an inch to it when you go and measure the external part of the airframe to drill the hole. And make your mark on the line you marked for your rail buttons. Make an X where you think the center of that motor mount ring is situated at.
Mark, can you show how to measure, please?
Hey, give me, I'm trying to clean up here. I was showing them what a rail button is so they know before he gets into details.
Oh, okay.
Make sure you guys all have the rail button. Make sure you guys have the screw that goes with the rail button. I only have machine screws, Frank, because I didn't get the other kit, so I don't have the exact screw that you guys will be using.
Okay.
I don't have a rail button, nor did it appear on my parts list.
So
It was on the rocket kit part list that was attached to the last email. There was a separate thing that you had to check both of those. Mark is showing what they would look like right now.
Little black piece, plastic.
They should have came in the same.
I believe mine were clear. If they might be a different color.
D'Angelo, we cannot see what's in your hand. Up just a little bit. Sorry.
There you go. You got them. Do you have the machine screws or the wood screws?
So it should have came in a bag, Scott, like this. Just a separate bag with 3 screws.
Is the
All
one
right,
next to the black one.
So some of you are missing the rail buttons.
So again, we apologize for anything that's missing. We actually physically went up to our Lock Precision for this to try and ensure that everybody received every piece. So again, if there's things that you're missing and we need to resend you anything, please get that list to Connie so that we can get it shipped out to you if you can't get it locally. And again, if you do get it locally, we can always reimburse you.
All right, so where were we then? Frank was talking something about airframe and lining up. Now that we got that far.
Okay, make sure to line up, measure the depth of your aft ring, motor ring from your airframe and how deep the aft ring is.
Oh, yeah, that way, yeah.
And then do that same measurement that you have captured, that depth to the external part of the airframe where you're going to mount your rail button on that straight line you marked, and add about 1/16 to 1/8 of an inch onto that, so you are almost in the center of that motor mount centering ring. It's not very thick. I think it's a 1/4 inch centering ring. So when you screw it in, you're hopefully hitting the motor mount ring, so it has something to grab onto. Use your drill to drill a hole where you marked the X where to put that rail button. Use your drill to drill a hole, a pre-drill hole. And once you have the hole drilled for that rail button, I want you to mix a little epoxy and put it in the hole.
Okay, so Mark's on the step that you guys are probably also on where he just marked the aft centering ring location where the one rail button will go.
I measured it and then translate the measurement to the outside, add a 1/16 because you're going to try and get into the center of that, the midpoint of that centering ring.
And if you're before or after that centering ring a little bit, as long as you get into the centering ring and you apply epoxy to that spot, that rail button shouldn't go anywhere.
Okay.
What was that measurement again?
Pardon me?
What was that measurement?
You're going to need to measure
You measure.
Oh, okay, okay.
Then add a 16th.
then translate the measurement, then add a 16th.
Okay,
The front.
and then, yeah, let's do the forward centering ring mark.
I don't know if everyone has, they need longer than the stick, right? So I'm going to use a measuring tape.
Yeah, if anybody has a measuring tape,
Can
yeah, get it
immediately
out.
have one.
Yeah.
Mark, why don't you do it the opposite way? Why don't you take the measuring stick and the dowel together and show how you can measure it with what the students will have
So you're gonna take a
together.
ruler and the dowel.
Yeah, I don't have a dowel, but I'm going to put two of my rulers together to make a long ruler. You know, assuming this is the dowel, we're going to tape these two together.
Does everybody have a dowel?
I think so, yeah.
Billy does not. So what is his alternate option if there's no dowel?
You can put two sticks together, two craft sticks and the ruler.
Because it doesn't have to give you stability. You're just using it as a measuring device. So you don't have to have like a bunch of control over the length of the two craft sticks that get added onto your ruler.
Okay, there we go.
Make sure your recovery strap didn't pop out.
Are we doing that now?
Yeah, my recovery strap popped out.
Yep, go ahead
You
and
should be
measure.
doing step 2.
Oh. I'm so lost. Chris, direct me.
So at this point, everybody should be looking at their airframe at the forward part of their airframe, the side without the fins. And then you're going to take your ruler, your measuring apparatus, and you're going to put it down until it touches the forward centering ring. And wherever that spot is, kind of hold your finger, make a mark, so that when you pull your measuring apparatus out, you can make a mark on your airframe. And that should tell you again where the the forward part of your centering ring is. So you're going to have to add that 1/8 of an inch again, so that you can get in the center of the forward centering ring. And that's where you're going to make your hole. You're going to drill into. So you again want to make sure when you're making the mark, it is on the mark that you made for the rail buttons. Does everybody understand?
Did you guys get all that? It was clear to me, but I've done it lots of times, so. Did you get that,
Andrea,
Aaron?
You might need to use something that's a little more rigid than the tape measure.
So translate the measurement to the outside and then add a 16th. And that should be where the center of that centering ring is.
Might not be exactly on, but you're going to be putting some epoxy in there anyways. It'll stiffen it up good if you're off by a little bit. We're trying to get as close as possible to that ring.
Measure twice and drill once.
That's right.
How you doing, Willie? Yours looked like your measuring stick might have been a little short. You good? Look at that.
And last time we did this, a couple people said that their measurement was different depending on where they touched the centering ring, because there is epoxy in there that you might touch. So that's why you're measuring a couple times and making sure that you're getting the same location each time.
Yeah, make sure you're hitting the ring, not the eye bolt or your recovery strap or something like that.
So when I put mine down into that hole, I try to make sure that first part going down in is not the part that's touching the airframe. So if I'm kind of like this, right? I want to make sure then that I'm going in the airframe so that this part is on top. So when the bottom part goes all the way down, it's going to hopefully miss the epoxy.
Also worth noting that if one person gets one measurement, everyone else is going to have a different measurement because we all put our centering rings in slightly different spots. So don't rely on what your neighbor's measurement was. You have to get your own.
All right, we got some marks.
And it's even worse when you have G10 centering rings.
And go ahead and put an X in the chat when you've got both of your X's marked on the outside of your airframe.
All right, don't forget to put epoxy in the hole.
We're not even there yet. We're just doing the X on the.
Oh, we're just doing the X? Okay.
You don't have epoxy or drills yet.
Drilled
Just
it.
putting the X.
Okay, don't anybody put the rail buttons in that we were talking about. Just mark an X.
Maria, I'm trying to understand your question. Is it supposed to be pretty close to the fins? Are you referring to the
mark?
Maybe
Oh,
about
it's-
2 inches.
Yeah, what is?
He needs a breakout. Anthony needs a breakout room.
So the
Kevin, maybe Bob too. You guys want to go? Maria.
Oh, we've got Taylor
actually,
too.
a lot of people.
Everybody.
Never mind. We'll stay here. Everyone's a little bit lost. All right. Do we want to start with the aft description again?
Yep.
Go ahead,
Let's
Mark.
start with the aft.
So just remember, look for the line that you drew earlier today, the straight line that's going down the side of your airframe that you penciled in. And that's where we're working from.
We're gonna call that the rail button line.
So the first rail button line is going to be the measurement from on the outside of the airframe to the aft centering ring. So
We got
probably
three.
about 1/8 to 1/4 of an inch. And then you add 1/16 of an inch and you make, so you're measuring the inside, then place your ruler on the outside of the airframe and make your mark the same distance plus 1/16 of an inch. Okay.
So come on, engineers, we're translating a measurement.
That's right. You're gauging that distance with another tool.
Probably great tool physics, translating measurements.
So the X is going on the line that you drew earlier today.
We get enough examples?
X
No,
marks
we
the
need more.
spot.
So is everyone good on that part?
If you're good, put a G. Anthony's good. Nikki's good. Oh, look at them all come in. All right.
One down.
Yeah.
One hole down.
Let's turn the rocket so we're at the other end.
I'm gonna translate the rocket, not turn it.
And
Transition.
we're going to take the measuring stick that you have put together. So probably your ruler and your dowel. On the ruler, put your ruler side up so that the ruler is up and it is going to be closest to the airframe. So the dowel is going to be about a 1/4 of an inch away from the airframe when it goes down to the forward centering ring. As you've done that, take and put your finger at the spot where the ruler touches the airframe.
Like I am showing.
Yep.
So I'm
Mark's
as
showing.
far as I can go. It's the other end of my measuring device is touching that centering ring.
So now Mark is going to pull that out. He's going to place that measuring tool on the rail button line. He's going to add a 1/16 of an inch.
So I keep where my thumb is, I keep this side fixed. On the other side, I'm gonna add a 1/16 of an inch and draw another
X. If you still need help and you don't understand that, put an H. Otherwise, we're going to assume everybody has it now. All right, if you are ready for the next, Taylor would like us to look at hers. And if you are ready to go on from this step, please put an R in the chat.
All right, Frank or Mark or whoever, Kevin, are you looking at Taylor's? Taylor was asking for confirmation.
It looks good, but I can't tell from here.
What are we looking at?
Taylor.
Taylor? Taylor, where are you?
and Anthony. You need to show your rocket.
Yep, Anthony still needs help.
After I find the length from the forward ring to the top,
Yep.
where do I find the middle or put the ring button? What's it called?
So we're
Rail
just putting that little mark at the same distance on the outside. So
Oh, okay.
if the
Put it
airframe
on
was
line.
transparent and you could see through it, you would put an X right at that centering ring. That's what we're trying to do.
Right, so once you mark your long piece of whatever you're using to measure, add a 1/16 onto that on the external part of the airframe.
So we'll make the 2 marks first to know where we're going to drill. Once everyone has those marks in the right place, and then we'll move on to the drill step.
Yep. Taylor, how you doing?
I think Anthony, did we answer Anthony?
Yeah,
Sorry.
Anthony's good now. He gets it.
Got it.
Yep.
Andrea, how you doing?
Yeah, looks good, Anthony.
You look good, Taylor.
I understand what to do. It's just a shock cord's in the way.
Yeah, when we worked on your centering ring, we put a pencil line on the air tube or airframe that should come pretty close to where your X should be.
All right, we all good? We're all on the same page?
Okay. So let's move to step number 3.
Okay, people, you have your drills with a bit in your drills. And we're going to be using a rail, besides your drill, you do have rail buttons. I think everybody had rail buttons except for one person.
Scott, we could just fix yours later, tomorrow, whenever, next week when I see you.
I can drill the holes, all right?
Yeah, you could drill the holes.
Sure, sure. And you're probably going to use the wood screw that comes with the rail buttons. They're only like about a 1/2 inch long.
So I only have a machine screw that I'm showing. If anyone can see Frank's screen, he has the wood screw. Basically the same. The wood screw has a point. The machine screw doesn't.
Right. Machine screw will work.
So we suggest you use the pointing screw, the wood screw, not the machine screw. There you go.
Maria and James, do you guys not have the drill
Chris,
bit?
you're muted.
I heard him.
Frank, I was just asking you, I didn't see the drill bit sets. Did they come with the 1/8 inch bit?
Sure.
Because
Yeah,
Maria doesn't.
we don't have them in the set, but we have a power drill at home, so we'll use them.
Okay.
So can we drill?
All you gotta do is make a pilot hole for these wood screws. Like maybe only about a 1/2 inch deep, if that. Just a pilot hole so you can center up your wood screw to drive it in with a Phillips screwdriver. But we're gonna add epoxy in that little hole before we install it.
Mark, you missed it?
Yeah.
Yeah, good. I did too, 2 weeks ago. I don't feel so bad now.
So when you drill the forward hole, you should feel if you drill into that centering ring that's inside of there. So I just finished drilling it and it went through the airframe, but there was no wood. There was no centering ring. I think I'm behind it actually. So my measurement was a little bit off. I'm gonna leave it as is. I think I'm good with that. I'll put epoxy in there and then drop that screw in there.
When you do your competition rocket, it's probably gonna be a bigger diameter rocket, and you're gonna have probably maybe a bigger motor mount ring, and perhaps your hand can get in there. And you notice that this your rail button kits came with a machine screw that you could bolt on the back side of the airframe, so you can actually screw and nut your rail button in.
Yeah, especially with the fiberglass kits, if your team has a fiberglass competition rocket, instead of trying to drill into a centering ring, you'll probably just use the backing nut. So you'll drill through the fiberglass airframe. Sometimes the fiberglass airframe itself will hold a thread. It's thick enough you can screw it in and it'll hold rigid. So I'm going to drill the back one. I believe it's probably going to get into that ring. So hopefully you guys are drilling your holes now.
And if you did miss the forward ring, no big deal. The epoxy will hold that in good. All you need is the rail buttons to guide your rocket off the rail. There's no big force that they're going to be flying off when the rocket takes off. The only time they're going to fall off is that you're going to cause it to fall off, because the rear rail button is the most crucial one when you slide it on, because I've seen them break off a lot when the kids get excited to put their rocket on the rail, and they'll have the rocket a little bit misaligned, and they'll snap that part off more than the forward one. That's for sure.
Mine did.
Right?
Try and make sure you drill perpendicular. Don't come at an angle. If your rail button is at a sideways angle, there's also a risk of damaging the rail button on launch.
Right, and once you drill a hole and you have your wood screw and you apply your epoxy in the hole, you might have to poke that hole a little bit so the epoxy sinks in that hole, because it's gonna kind of bead up. If you got something small, a small screw or something, you could poke in that hole, or take your drill bit and just poke it in that hole. Don't forget to wipe it off after that. And like Mark says, make sure it's straight. You know, it shouldn't be cockeyed or misaligned. And do not over tighten the rail button, because if you have let's say you have a nut and a nut behind it, and you squeeze it down, you can actually squeeze that thimble down and it won't fit on the rail. So you just put it on there snug, not real tight. Let the glue set and you'll be good.
Mark, is the reason that the whole away from the forward centering ring is okay is because the screw will be epoxied to the side of the centering ring?
Yeah. So because I'm going to put the epoxy in there. I know the centering ring's right there. I'm going to assume that all of that is going to hold that forward rail button rigid.
Sure, it will.
So I just missed it. So if you did miss the ring, it's kind of your call if you want to try and re-drill the hole. You might have a better idea where the centering ring is then. If you missed it, if you're forward of it or behind it, you could drill a second hole if you want. Or you could just load up with epoxy and it should be rigid enough.
So how's everybody doing?
Yeah, where's everyone at? Are we epoxying yet? Everyone get their holes in?
Looks like Zoom University is good.
Yes.
Willie, how you doing? Good? Oh, he doesn't have. Oh, we got a lot of R's. Scott's good. Scott, you're good.
Arlen gave a thumbs up too.
Andrea, how you doing? You got your holes drilled?
So I have the markings right here. I'm not sure if you can see them.
Okay, let's drill them up.
Oh, I can't. I don't have a drill.
Oh, you don't? Do you have a X-Acto knife?
I might.
You can take the X-Acto knife and kind of spin it on that X. So you just kind of make a little indentation, and then you can take your wood screw and just drive it in.
Okay. Well, I don't have the rail buttons or those screws anyway, so.
Oh, you don't have them either?
Rail buttons.
Yeah, I don't have any of those.
How's everyone else doing? Nikki? All right, looks good. Yep. Willie?
Scott's
In the assembly of the rail buttons, how does it go? Screw, nut, and rail button, or is it some other order?
So we're not going to use the backing nut. We're just using we're not going to use this part. We're just using that part. And we're just going to drill it right into the hole, right?
Yep.
All right.
So you put the epoxy in the hole first, and then you just screw it in.
Okay.
So if you're at that step, just mix a little pot of epoxy. You don't need much. Put a dab in the hole, and then screw it in.
Okay.
Tyler, how you doing?
Pretty good. How tight do I screw the screw in?
Just a little snug. That's all. Don't over tighten it.
Let the
Are using the
just bottom it out. That's all you got to do.
Are we using the flat screws or the pointy ones?
The pointy ones.
The pointy ones.
Okay.
The
I have to cover screws with you, Chasen. I didn't know that was the chemies.
That was a name? Willie, how you doing?
I think I'm gonna wait until I have an actual drill to do this because it's kind of hard.
Do you have an X-Acto knife?
No, I do not.
Do you have anything that could pierce a hole of some sort, just to start a hole?
How about a push thumbtack?
Or yeah, even just a thumbtack.
Sure, I can try that.
Didn't we send X-Acto knives to everybody?
Yep. Well, they were in a group, so we might have sent them only 2 or 3.
Got it.
Okay.
So while folks are finishing up and screwing in their rail buttons with the epoxy, Do you want to go ahead and start your rock sim, Aaron? What do you think?
Start that. I think there are a few people that were sort of behind. I wanted to kind of review what I've done up to now.
We're just Taylor using the pointy screws. That's something that can like really dig in, you know, the one that can dig in the most into the wood centering rings.
Oops, wrong one.
So finished product, your aft centering ring, your forward centering ring, or your forward rail button, and aft rail button.
Found my rail buttons. They were with the recovery.
So is now an okay time to start Roxanne?
Yep, go ahead.
So I have my screen up. I just wanted to review. I know Tyler, I think it was, hadn't had his motor in.
Yeah.
Or so you have your motor in, right?
Yes.
Does anyone else not have their motor in the Roxim? Sorry, like they have an H219 loaded into their Roxim model. But so after that, I had added these centering rings that were more accurate to our specific model and changed these fins. So I just wanted to review that real quick. The model you downloaded came with these forward and aft centering rings. And the fins had the improper tab or tang, I think Frank calls them. So to fix the tab length, you double click on the fin set, go up to through the wall fin mounts, and then click this button that says calculate fin tab length for me. So before this was an incorrect length like that. See down here, it's not fully reaching the motor mount tube. If you just click this button, it'll reach the motor mount tube. So was everyone able to do that? Let me know if you can. So I don't see any response. So cool. The other one was the centering rings. So this forward centering ring, you guys had an 11-inch motor mount tube. So I put it at how close you put it to the top, a ½ inch below. I put it 10.5-inch length from the top of, or from the bottom. So that's a ½ inch below the forward section of the motor mount tube. And then same with the aft centering ring. If you open that up, that's back here. I just changed the location so it was right up against the fin tab, which is what you guys did. You pushed it in as far as it could go until it hit the fin tab. So I just used the drag, this drag bar for location. And then the material, plywood is, we'll just leave the material for all those. But if you have like fiberglass, you can change it here, but for plywood. And then I had added your middle centering ring. So this mid centering ring here did not come with the kit. So I had click this main airframe tube and then added over here, there's a button, centering ring under add new component. You click on that, change the name to mid centering ring. It should have the right size for these, but then change the location to the top of the fin tab. Right here with this location bar. So does everyone have 3 centering rings?
I don't have a mid centering ring. Which one do I pick?
Oh, over here, the add new components list. You have to click this main airframe tube first, and then it will allow you to click this centering ring button over here. So just click on that.
It also says to pick from database.
Oh,
and I
forgot about that. There is a lock precision. Go down to lock precision and choose the one that has the part number CR 3.00 to 1.52 inches. That's the 3-inch outer diameter and 1.52 inch inner diameter. So choose that and hit OK.
Okay, got it. Awesome.
Cool. Sorry about that. I forgot. Needed to choose from the database. And then, so from now, and you guys should have this H219T in here, but just to review, we had gone up to File, Reload Engine Data, this Download Engine Data tab. We had typed in H219 and searched it, came up with one match. We clicked on that and clicked Download Selected Engine Data. And then we saved it in the folder it gives, which is the Roxen data folder. I've already saved it, so I'll click cancel. And then before we click OK, we go back to this engine data file and it shows up here and you have to highlight it and then click this add button. So you should see aerotech219t.rse in this selected engine file list on the right. Once you see that, then you can click OK. Then when you go to prepare your launch and choose the engine, you should be able to find it in the list. And then engine delay, 14 seconds, engine overhang, 0. And then just to review, don't change anything here. This is motor ejection. Don't change anything here. This is the back end calculations. 72-inch, that's not the default, so make sure to change that. You can do this launch angle 5 degrees if you want. And you can add some wind if you want. Do that calm 0 to 2 miles an hour. You can do light wind. And then don't touch anything here. Click launch and it'll, I don't really care too much about the animation, but this one here is, so as currently built, it has it going to 2519 feet. And off the, to make sure it's going fast enough, we need to look at velocity at launch right here. So 63 miles per hour. We wanted at least 50 feet per second, whatever 63 miles an hour is. 92 feet per second. So that's plenty high. So that's good. So that's where we are right now. Was everyone able to run one simulation with the H219T motor? Okay, cool. One next level, since you guys just installed rail buttons, I think that's an important thing to reflect in here. So the way we would do that, it's a aerodynamic object that's on the side of your rocket. So we generally treat it as a fin and a custom, I think it's a custom fin we usually use. So make sure this airframe tube is selected. Add I'm just gonna try regular fin. And don't choose anything for the database, click cancel, because we're gonna have to size this correctly. So change the name to rail, actually, we'll do the aft rail button, and then we don't have 3 along the outside, we only have 1. And then,
I have 2 rail buttons.
well, we only have 1 aft rail button. We'll have 1 forward rail button separately. But we have to, this only adds them like in radial position. That's the right. So we can only add 1 for now. So it's about a 1/2 inch by 1/2 inch by 1/2 inch. So tip cord, 1/2 inch root cord, and then the span 1/2 inch. It should populate everything.
Aaron, did you mean to have your semi-span at 6.5 inches?
Oh, no. Sweep angle, it's a straight up, so sweep angle is the, like this swept backness, so 0 degrees. Okay, so that kind of looks like a rail button there. And we want to make sure it's positioned correctly. So in this bottom, you can click this little icon and go that aft view. And that'll show you as if you were looking from the bottom. And then you can go up to this 3rd tab, radial position, and go in between the fins, which is like 45 degrees. You can just type that in. And then it calculates the mass as, because we have plywood, because we do have a screw in there, so it's going to weigh probably, what, 10 grams, I would think, with the screw and the rail button. So I might be inclined to mass override that to 10 grams, just to reflect the mass. So you can click this tab up here, mass override, and put 10 grams. And if you go back to that general, it'll say, oops, you gotta check this button, sorry. And then don't change the CG. And that should be it. Click OK. And
your thickness.
Oh, yes. Right about that.
Under material. 1/2 inch.
Would there be a match for the material?
Doesn't, I don't think, polycarb.
And then what, a 1/2 inch thickness? It's a round.
Yeah, so it's square, like cross section is square.
And you can check this 3D view. I guess you could try that here. Scroll up or down to see if we can find it.
Aaron, the question is, can you duplicate the rail button settings for the forward one when you do the forward rail button, or do you need to do it all over again?
I couldn't figure out a way to duplicate it. Oh, so there it is.
Yeah, not that I know of. Roxanne doesn't have that
Yeah,
functionality.
I'm trying to do that with the centering ring and I couldn't figure out a way. So I think you have to do the same thing.
Yeah, Open Rocket does, but not Roxanne.
Oh, okay.
And we also have to place it lengthwise where it's supposed to go, right?
Oh, yes. Sorry. So place that above your
Good catch, Aaron.
centering ring. Yes, thank you. I'm gonna do that real quick. So location, go back to the, just drag that so it gets over that centering ring. That's close enough. Okay, now I'm gonna add the second centering, or the second rail button. So add a fin, cancel the database, call it forward rail button. It's a single fin. Change the sizes to 1/2 inch tall, 1/2 inch wide, and 1/2 inch long, which includes thickness. That'll sweep angle, put the 0. Make sure the span is 1/2 inch as well. Radio position 45 degrees, so it's on the same line that you guys drew on the door.
Aaron, we have about 3 minutes left, just so you're aware.
Okay. Override the mast 10 grains. And then make sure the location is above your forward centering ring. And then click OK. So we should have the rail buttons there. Was everyone able to add at least one rail button? The second one, you should be able to, it's the same process. If so, I wanted to go over parachute sizing as well. We have a parachute here, and the one that we downloaded had a 36-inch size, and it looks like they overrode the mass. So that's something we could check. I don't have a scale here to check my parachute, but we want to make sure it hits the ground at less than 20 feet per second. So currently it shows 20.3 feet per second. So that's actually sized correctly. That's, if you guys were at Mark's Structures webinar, that's one aspect of sizing. If we had, I'll just test this out. If we had done a smaller parachute, like a 30-inch chute, this descent rate would be 24. I mean, that's okay, but that's kind of high. And then if we had done higher, I mean, slower is better, but it's heavier as well. So
Yeah, it's a 36-inch chute and it weighs 66 grams.
oh, 66 grams. So you can change the override. And a 6-inch, you said?
36-inch.
Okay, cool. And then it's, I think, ripstop nylon. And you can, these look accurate to me, shroud line length. So you can click OK. So that's about what I wanted to cover. If you want to make it more accurate, you can add little mass components for more epoxy or the eyeball you made. But I think I covered how to add this epoxy, so you could just do that again for other the eye bolts. And we're going to add a fire protection cloth. You can add that as well as a mass object. But that's, we should have a fairly accurate model. If we run that again, just click that and we'll probably end up at a little lower this time. It's at 1,900 feet. we're still coming off the pad at 63 miles per hour. That's like 90 feet per second. So that seems pretty good to me. Anyone have any questions at this point? Roxanne?
For the descent rate, did you set it or is that automatic for the parachute?
When you choose a parachute size, it shows how fast it'll come down as, but we have an ideal descent rate that we want, which is no higher than 20 feet per second. So ideally, we would choose the parachute that would lead to a descent rate of around 20 feet per second.
Okay, sorry, I think I had the miles per hour. That's what I was getting different numbers.
Oh yeah. Okay, well, I'll hand it back to Frank and Mark. Continue to build.
Okay, here comes the fun part.
Hey, Danielle, or sorry, Danielle or Chris, can we show Frank? Frank, do you have it set up? Because I know you're going to demo a quick link, which we don't actually show. The slides show a knot.
Right, right.
Not the quick.
Does anybody have how many quick links do people have? Do you have 2 or 1?
You just put your number of quick links in the chat.
There you go.
1 or 2.
We could tie it too, I guess. We could just tie everything.
And let's not jump too far ahead. So the first step is what Frank was doing, which is pushing the shock cord out of the motor mount tube through the forward end of the airframe.
The aft end, you mean? Pushing
forward.
The aft end
Yeah, but
out
you're pushing it out the forward end, like I said. Yeah.
So with whatever measuring device or long stick you guys have.
It's generally probably about 3.5 feet from the end of the loop you have exposed. Go ahead and push your recovery strap out. If it's inside the tube, push it out. If you got a ruler or a stick or something to push it out or shake it out, it should come out and unravel it. And I believe this shock cord is approximately 12 feet long, so 2/3 would be like 3.5 feet from the end.
All right, we're gonna go really slow, step by step through this part because it gets kind of tricky. So as long as we can see your shock cord on the screen, we'll know that we can move on to step 1 on this page. So we're just gonna wait until we can see everyone's shock cord. Make sure it's out. There we go. I think Willie, you're still pulling your shock cord out. Great. Marlon's good.
Tyler.
Looks like James has got it. Maria.
Yeah, we push it
Pull
out
it
the
all the
side,
way
right?
out, Tyler.
Correct. Yeah,
Okay.
out the forward end.
Mine still has the Scotch tape on it, so it's not unraveling.
If you can get your hand in there, you need to try and get it out somehow.
Yeah,
Hook
get it
it
out
from the
somehow.
other side. You need to pull it all the way out.
Shake it out.
That's kind of what we said. We didn't want you to tape it too much, just tape it once, lightly around. You can probably shake it out. Tyler, did you push it out the forward end or the aft end? Okay.
The
Yep.
one without the fins, yeah.
Good.
All right. Taylor, you good? Sorry, I didn't see you.
Does everybody have the recovery strap out?
Taylor looks like she does. Okay, I think everybody does.
All right, step
Okay.
1.
All right, step 1. Okay, take your loop on your recovery strap, put it on your finger, stretch your arm out and go to your chest. And that would be 2/3 of the way from the booster. 1 arm length. Yep. Just like that, Aaron. You got it. Yep.
Approximately.
Yep. Approximately.
I
Full
got long
length
arms.
out. Full, put your arm all the way out straight and then hold the end and then come to about your chin.
Yep.
And that'll be a good length.
Now you have an option. Either tie a loose knot, like this, right at that point, 2/3 of the way. Or you can tie an inline slip knot if you like. It's your fancy choice.
Do we still have the photo of the slip knot, Danielle, to go back to, just in case somebody doesn't know how to do a slip knot?
Zoom University has it down perfect.
Yeah, but this doesn't show exactly the way that they'll need to do it. This is different.
Okay.
Yeah.
All right. Sorry.
So just watch.
I need to show again. I finally got my cord to fall all the way out.
Yeah.
Okay.
Arm
2/3.
length we're talking about.
Right. The length. Take your forefinger, stretch it out, and take your other hand and go to your chin like this.
Looks good, Scott. Okay. Next, Frank.
So from
Mm-hmm.
And then tie a knot at that location. You can either tie a inline slip knot like this, or you can just tie a regular loose
Overhand
knot like that.
Slip knot or overhand knot.
That's right.
Yep, Aaron's got it. Good job.
As long as you have a loop in place there.
Okay, let's go a little bit slower. I think, Willie, you look like you're struggling, right, to get that? So Frank, let's go step by step. Oh, no, you have it.
No,
My apologies.
Yeah, Willie's got it. It's just a big loop.
Sorry. Nikki, do you have yours? Okay. Perfection. Okay. Does everybody have their knot? Anybody
good.
not? If you do not, put an H in the chat. Okay, nobody did. We can go on to the next step.
Okay, everybody grab their parachute. Lay your knot down on your table. Everybody grab your parachute and untangle your shroud lines.
So Mark is showing what it looks like laying it down on the table.
Lost this video.
So there should be, I guess, 4 strands to untangle the shroud lines.
4, yes. Four or 8, we're having a look at it. As soon as everybody have their shroud lines kind of separated in order. Nope, I know it takes a little while.
Still got a couple of people working on it, so we'll just pause here. So again, there's 2 methods you could do it the way Mark is doing it, which is up on the screen right now, where you have it laid flat on the table. And then you're just worrying about untangling your shroud lines, the bright green lines. Or you could be doing it the way Frank is doing it, where he's lifting it up off the table and kind of untangling it that way.
Marlon, do you have yours? Are you still working? Okay, I think you're showing it. Okay, perfect. Thank you.
Aaron, you might know a little bit about parachutes.
Jason, how are you doing? I see your back.
Oh, yeah.
And you're good, D'Angelo. Perfection. Billy looks good. All right. I think we should be able to go on to step 3. Are you ready, Jason? Yes. Okay, let's go on to step 3 then.
I'm going to show Mark so that Frank can focus on explaining the first time, and then we'll probably show Frank too. So.
Okay, so I think 3 and 4 we're tying the shroud lines as opposed to the quick link. So I can do that as well. And then I don't know if Frank wants to do quick link or not.
I don't know, does everybody have 2 quick links?
And Andrea does not, but everyone else said that they have at least 2.
Okay, Andrea will be using the knot method at the 2/3 spot, and that's going to be
Which is what I'm about to demo.
Okay.
So we're gonna take the shroud lines we have in our hand that we're having sorted. We'll put them through the loop that you just created on the black. I think you have a black shroud line, maybe or a black shock cord, and then you just feed the parachute back through. That's one way to do it.
Mark, can you get closer to the screen so we can see a little bit better?
Let me back that all up.
See the example, 1, 2, and 3. Locke puts their parachute right at the nose cone on a single deploy rocket. They don't put it 2/3 of the way. And I'm teaching the F and L here to put it 2/3 of the way because that's how you'd set it up for dual deploy, because they're going to be doing dual deploy in their project. That's where you want it.
So one way to do it is just to put those shroud lines through the loop and then feed your parachute back through, or your shroud lines back through that same loop.
Just go with number 2 right there, where you take your loops on your shroud line like this and put it through the loop you made, and put your parachute through that loop of the shrouds, just like Mark did.
So I just did what Frank's describing. That's one way. There's various other ways. Everybody see that? You guys getting that?
Hey, Kevin, do you tie a knot in your shroud lines?
I'm one of those people who does.
Yeah, okay.
But
Yeah,
I'm using a quick link at that point.
Same here. I'll do a quick link with the overhand knot on the, which I'm about to do too.
Right.
So
Us guys that fly a lot, we like to tie a knot in the shroud here like this, because we want to keep our shroud lines equal on our canopy, so they're not lopsided, because if they come out lopsided, the rocket will either float away that way or that way pretty far. So you want to make sure your shrouds are all equal on your canopy. So that's why we tie a knot up here to keep it equal, so it doesn't get hung up. Knot. That way you have a little loop to put your parachute through when you want to hook it up.
Okay,
So
so
you got your knot right
let's-
here. Go ahead.
Let's go back. I see several people still trying to figure this out. So,
Okay, except for the one person. There's plenty of people that have two of these quick links. If you got your knot or your loop, put your quick link in there. Lock your knot up or tighten up your slip knot, and you have a multi connection point for your parachute, where you don't have to loop your parachute through. All you do is put the shroud line through it like that. And you should have your little orange deployment protective bag for your parachute.
Oh yeah, I forgot that.
Yeah, you can put that in your quick link too. Screw your quick link and you are done.
So as a reminder, step 1 was when we put a knot in the shock cord, the red cord, right?
Step 1.
That was step 1. And then your second step was to put a knot in the shroud lines.
Yep.
Okay, so that shouldn't be too confusing, just one knot on each cord.
And you have a multi-connection for your quick link when you put your quick link on your knot on your recovery cord.
Everything comes together at the quick link.
Yep.
All
So
right,
you're gonna take your quick link and you're gonna attach the knot that you made with your shock cord, and then the loop at the end of the knot with the shroud lines, and your parachute protector, the bright orange thing. And you're gonna put all 3 of those loops onto the quick link.
is there anybody who does not understand the instructions and needs further details?
Andrew probably does, or she got it down.
I think I do, because again, because I have enough quick links, but I'm not sure when I use a quick link or when I tie the knots.
All you have to do is tie a knot on your recovery and tie it onto the quick link. And then you can open up your quick link to attach your shroud lines for your parachute and your chute protector.
Okay, so I need to go back to the tying the knot into my
shroud lines.
Shroud line. Oh, sure. Yeah, go ahead. Yeah, you tie it back like about, I don't know, 8 inches back. And make sure your canopy lines are equal. At, you know, these lines here, so your canopy is not sagging, so everything's equal before you tie your knot.
Aaron's got it.
Andrea, I saw you holding up the knot. It looks good. So I didn't want to interrupt Frank.
Zoom University looks good. Bob Justice, you look good.
Anthony's showing his.
Where, yeah, I see Nikki's is good. Taylor looks good. Yeah.
Nice.
Anthony, yeah.
Andrea,
she's working it. She's almost there.
Yeah, she's got it. You got it. Good job.
So you put the little, yeah, the little orange guy, you put him in there as well. There's a slot in the little orange. Yeah, put it in the quick link, Andrea.
See, I didn't want her to use that quick link there, but that's okay.
She only has one.
Oh, she only has one.
Yeah. I want her to use
that.
I want her to use the quick link on the, that's what I was talking about. So she's gonna have to tie knots in her her shoe protector and on her parachute.
Do you want Kevin to go
Yeah.
with Andrea to show
Yeah.
that? Okay,
Yeah.
because everyone else has two.
James, how you doing over there? You guys good? All right. Yeah.
Because Android, we're going to use that only that quick link you have left. We're going to use that to hook up to the sustainer.
Yeah, I understand.
Okay, thank you.
And then
Is this correct?
Yes, it is.
Okay.
Yep. Now tighten that tighten
Yeah,
that up
tighten
so
up.
that
Yeah,
it makes it.
yeah, tighten up the quick link so nothing falls off. Yeah, there you go.
Yeah, looks good, Scott. I think you got it.
Okay, Andrea, I'm gonna send you in with Kevin so he can walk you through how to do the knots with just the one without a quick link, okay?
Everybody got it? Looks like it.
Okay, put an R in the chat when you're done. Jason, are you done? How are you doing? Oh, there you go. I just saw yours come in.
Is the next slide hooking it up to the sustainer, or did we miss that?
Taylor, how are you doing?
Have we used the second quick link yet or not?
Okay, thumbs up. Good.
No, we haven't, Willie. We're about to get to that.
Okay.
I think everybody looks like they're good.
And this
All right.
step is not on the slides because we weren't sure who would have quick links. So I think Mark, do you have a quick link for this part?
I got quick links at the evening here.
Okay, so Mark will demo and Frank's gonna walk us through this step.
I'm a big quick link believer, so I love to quick link everything. So it's a quick change out in the field. You tie with knots, you can't change it. You got to untie all your knots and then retie everything. So I think we're going to go on the very end of your shock cord. There's another loop, right? Let me take this off first and show you the loop. Right. So the other end of the shock cord is not tied to anything yet. If you guys can get that in your hand and then put the quick link around it or through it. You guys all have your quick links, right? You have a second one. And then we will just attach the other end of the quick link to the eye bolt on the booster or the sustainer section, right? There you go, and just close it up, and that's all there is to that. Now everything's attached to everything else. We simply need to pack the parachute inside and close up the rocket, and it's ready to go.
So go ahead, Mark, with the folding of it.
Yeah, this is Aaron's method of, I'm gonna have to learn this one, so. Learning on the fly here too.
And I think that's an important, as we continue to say this, we are showing you one way during the certification. There are many ways to do different steps, and those are things that we touch on, but you can look into the many different ways of doing it.
It's user's preference.
Okay, are we ready for that? Are we on that slide? Because I just got I only have one screen, so I'm only on the.
We are.
Okay, so step one, right? So you lay your parachute flat and make sure your shroud lines are untangled. So just like I have on the table in front of me, I have all my shroud lines kind of on one corner. See you guys folding, right? I mean, sometimes it's all messed up, right? So you'll just have to kind of fold it over and step 2 kind of explains that. It's you're positioning one shroud line. So you could take, say, you know, if I had it all messed up, for example, I'd take one shroud line and then I'd fold it over, add a second shroud line, fold it over again, third shroud line. By the time you fold it the 4th time, all your shroud lines should be in line. Oh, Aaron's, I don't know what he's doing there. He needs that lander, the Mars, the lander thing to help him out, maybe. I don't know. Everyone get that far? Everyone get that step? People still folding?
Yeah, your shroud line should be almost like in a single line next to each other. Not tangled up, but neatly overlaying each other.
So, yeah. So other guys, Aaron's also kind of showing it there. I don't know if that's a video or it's real time, Aaron, or what.
It's real time. It's on my floor.
Everyone get it folded? Everyone get it folded up? Looks like everyone's ready to go. So next slide, step number 3. Once you get it all folded up, it should look like the picture on the right. Hopefully you guys are almost there. Willie's working a little bit. And then the next step you'll do once you get your shroud lines, parachute, you'll fold like a zigzag. So you'll just kind of fold it over and back again. You're just trying to shorten the length that it's packed, or the volume that it's packed in the airframe. You guys saw that? Just kind of did a quick once over, once back. Ooh.
You maybe pull your camera down closer, Mark.
So once over and once back, little zigzag, making a little Z, sorry. And then step number 5, next slide. We roll the parachute into a cylinder. So roll it up into roll it like a burrito.
Okay, now this example shows a pretty large chute protector. You're not getting a very large chute protector to encase the whole parachute into it. So in this situation, we have to put the rocket down on the aft end with the open end facing you on the ground. I can't see this here. Hold on.
Yeah, I don't know where Frank's going with this.
Yeah, I don't know either.
So just the example in 6, 7, and 8 steps of this slide, the cloth is not big enough. So we're gonna have to do an alternate method, is what Frank is saying.
Because of the chute protector isn't that large.
It fits.
To protect the whole chute. So what you have to do is take your chute protector and put it on top of the booster section like a pancake. And of course, I don't have a real good round burrito going here. And tuck it in like that so that the chute protector is kind of cupped inside the booster. So when the ejection gases come out, it doesn't hit the chute at all.
In a similar way to just do what Frank said, right? I have the chute in my hand, I just rolled up, instead of putting the parachute, instead of putting it flat like in the PowerPoint, you're just going to put it over top of the end like that.
Right.
And then you're going to put that whole thing into the airframe.
Right. Of course, always put before you put your chute and your chute protector in, take the 2/3 cord you have in, put it in first.
So
we're probably gonna have dog barf in there first. And then we put the majority of the recovery cord inside the tube before you put your chute in. Because the recovery cord takes a pretty good hit of hot gases and it's not gonna break. So you got a little bit more of a buffer there too for protecting the chute, along with the dog barf and all this cord. So then once you get most of that cord in there, you take your chute that I already stuffed in here on top of this.
Right. So get as much shock cord as you can in there first. And then with the orange parachute protector facing down towards the motor mount, you'll end up putting your parachute in to the rocket.
Right, just like this. Don't look at my sloppy job, but make sure that chute protector is facing the ejection charge and covering the chute. And
Yeah, so you see in my hand, I'm holding it right. So I have the burrito and the parachute protector just on the one end. And then I'm gonna hold it facing down.
There you go, perfect.
And then just continue to stuff the shock cord, the rest of the shock cord in there until you get to the booster or the sustainer. That on, hopefully they join. Oh, mine don't. I have a little thing on there. You may need to sand if you've damaged your airframe.
Oh, you got a burr on there?
Yeah.
I know, that stuff happens.
And just so you guys know, we have about 3 minutes left to this segment.
That's all I got. You put the two sections together and your rocket is ready to go.
Great. All you need is a motor.
And so this is the kind of stuff that is not just you do it once and it's done and you leave it. You're going to want to practice this, and on your certification launch day, you're going to want to take your parachute out and refold everything and check it and make sure it's good. Because a lot of times it can slide down in the airframe in transit. Your chute protector could slide off of the parachute.
Do I?
Yeah, I think I got it. Yeah.
I put the protection downward, right?
Yes.
Okay.
And voila.
When you've completed this step, we should see your whole rocket put together. Aaron Yazzie, good stuff. We see that full rocket. Scott, we see the full rocket. D'Angelo's full rocket. Willie?
Jamie Maria.
Congrats, guys. You've just built your first level 1.
Look at you, Nikki, in that 70 and 80 degree weather.
Good job, Taylor.
What do I do with all the spare parts? Am I supposed to have spare parts?
Yeah.
Yeah, they're probably
Some people are missing parts, some people have spare parts. It all averages out in the end.
I had spare parts when I built mine 2 years ago, so that's totally fine.
And with that being said, everybody's done, right? And ready to go. So Aaron, would you like to go ahead and start recovery?
Yes. Everyone open to page 36 of your handbook. Follow along. The recovery electronics will not be used on this rocket, but they will be used on your competition rocket. So we just wanted to give a kind of a quick overview here and more for reference for your competition. So there's flight computers, altimeters, and trackers, but the altimeter, that's the barometric sensor that shows how high you go. And yeah, it's normally a barometric pressure sensor. And that's something that you could use in this rocket. I add one of those in that figure 9-6. The bottom example is a Jolly Logic altimeter 1. And I use one of those in my lock precision rocket just so I know how high it went. But and those you can fasten to that quick link or where the fire cloth, parachute, and shock cord came together. But other altimeters, you'll have to add to an avionics bay, like some of you are doing for your competition rocket, and those could add GPS, accelerometers, or other flight computer functions on them. But the main function for the competition rocket is dual deployment. So the motor ejection will kick out the main parachute at apogee, but the drogue parachute at apogee, and then the main parachute somewhere between 300 and 1,000 feet will have to be initiated by electronics and black powder charges. And just as a quick review of that, you need to have enough black powder for the size of the volume of your rocket. So like in the one we just did, you have the length from here all the way down to your forward centering ring. That's probably like a good, at least 24 inches or so, times the 3-inch circle of the diameter. So you get that much volume, and you can use that to size how much black powder you need. Usually it's around like 1 to 2 or even 3 grams. There's equations in the handbook that you can do that with. And yeah, so ejection, altitude, and location tracking is the other thing we recommend for the competition rockets. So like a GPS tracker or something of the like is another type of recovery electronic, because these rockets that you build, if it's a clear day, you'll generally be able to see it with your bare eye the whole flight, and you'll be able to track it. You can even like video it with your phone and take a picture of where on the horizon it falls. But if you get any higher than like 3,000-4,000 feet, you won't see it. So you'll need some kind of tracker to get it back. And then wanted to go on to when you choose your dual deploy rocket. These are just some overview guidelines, but there's many different vendors. We used Lock Precision for this one, but we gave some examples there, and there's the top link has multiple suppliers there. And then for our competition, it's a bit old, it's 3,500 to 4,000 feet. So you'll need to make sure that the kit can get up to that with any of those motors, and the parachute can safely descend your rocket to at 20 feet per second or below. And then we talked about that main deployment. Your dual deployment electronics will need to deploy your black powder at around that, or 500 feet above ground level. Any questions about recovery electronics or dual deployments? Those aren't for these rockets, so we can always help later if we have questions on that. All right, I'm going to pass it off to Frank to go over launch site safety.
Thank you, Aaron. Oh, let's see, with FNL launch, if you're going to be certifying your rocket, we have the range safety officer that will be looking at your rocket first. Always be prepared at a rocket launch for the RSO to inspect your rockets where your center of pressure is and center of gravity. He'll be pulling on your motor retention. He'll be pulling on your coupling friction fit where your parachute and sustainer separates. And he will make sure your rocket will fly in a normal manner. Launch pad safety officer, he is usually responsible for the status of the range, make sure everybody's clear. He makes sure the airspace is clear. Even though we have an FAA waiver in the area, we still have to watch out for approaching planes. And of course, the weather. Launchpad manager also will assist you in mounting your rocket on your rail if you need to. Launch failures. Do we have a slide for that, or am I going to talk about launch failures?
A link to the video.
Yeah, that's right, there is.
Do we want to watch it, or we didn't watch it last time? We could keep going.
Yeah, I think we can keep going, and that's something that folks, we can send out if we need to.
Yeah, typical launch failures. Okay, we'll go. Okay, typical launch failures are motor failure, or usually it's human error on not doing a checklist with your altimeters, or not loading enough black powder in your rocket, or not using the right shear pins. There's all kinds of avenues to look for when you're launching a rocket. Be wise, learn from other people on the field, and do a lot of reading. Next slide, please. Certification, of course, FAA waiver is required, 45 to 90 days. We do secure a 2-year waiver now. They've changed it in the last couple of years that our waiver is good for 2 years at the particular location. This group, our particular group here, we have to have insurance to fly at this field with the landowner, which is the DNR. When you come to the launch, Tripoli requires a you have to register your rocket with the registration person. The airframe and recovery and the motor is required to be listed on the flight card. Also the electronics, but electronics aren't required if you're doing single deploy. And if it's a first flight, post-flight inspection on your certification rocket, we can't have any zippers. We can't have any torn, wore out, broken fins. The rocket has to actually be flown at the pad immediately upon inspection, if it's possible, after your certification flight.
Just stop 1 second, because I think there isn't, not everybody knows what a zipper is. Aaron, can we spotlight Aaron just a minute? And he's showing you, I believe, what a zipper is, correct?
It's not quite a zipper.
No.
This is a lawn dart.
Oh, a lawn dart. My apologies.
We talked about zipper at the structural, if your teammates were there, if any of the team was there.
Yeah, a zipper is this shroud line is.
The shock cord tears into the airframe.
Yeah, and then it rips a tear into the airframe.
Kind of cuts into that like a piece of dental floss. That's due to early ejection or a late ejection. Or your shock cord isn't long enough. How's that? It's usually deployment at a high velocity. It'll do a zipper, regardless. Christine, you want to talk about the certification for Wisconsin Space Grant on the motors and that?
Sure. So for your certification, each one of you will receive 1 motor for your certification launch. And so, and I'll go over how motors are transported, et cetera, in just a minute. And then you'll have to have your application for certification, which is a form that Tripoli or NAR will provide to you. And what we're asking is that you send them to us so that we can submit them all together and pay for them. So you're going to take a picture of them, and then I'll be able to pay for it for you. And then the level 1 is for just our workshop attendees only, right? So you guys receive the level 1 certification. Other folks on your team are more than welcome to go through the process. It's just not going to be sponsored and paid for by Wisconsin Space Grant Consortium. Next slide. And so with your mentor, we need to do a little bit of footwork before the actual launch day. Sorry, I'm just pulling up another screen so I have some information. So with your TRA or NAR mentor, you need to determine where you will be launching your rocket. That launch site needs to be, and we went over this with the advisors the other day, but just really want to make sure you understand, they have to be conducted at a NAR or TRA sanctioned / insured launch site. Okay, so it just can't be anywhere. It has to be at a NAR, TRA sanctioned, insured launch site. You must have a certified range officer inspect your rocket prior to launching. Okay, and that range safety officer cannot be your mentor. So it needs to be somebody who's impartial and is not your mentor. So we also will need to know if you are traveling to your launch site, what the travel budget is. So that needs to be submitted. We're asking that you do that by Monday, if at all possible. We gave everybody the heads up. So the launch site, where are you going to launch, your travel budget, and what's the date that you're going to be doing your certification launch. Our hope is that you can put tandem the competition launch and the certification launch. If that is not possible, then you just need to let us know that and then what the cost will be. So we will also need to know who is the TRA or NAR member who is going to be conducting the certification launch. We'll need to know the address and phone number of the individual who has to be level 2 or level 3 certified. Can't be level 1, has to be level 2 or level 3 to receive the motor shipment. And that information needs to be given to Connie. Couple of other notes that I want to make is, I just want to make sure I haven't forgotten this. And so you know, your motor, when you choose your motor, that is not going to come directly from WSGC. That will be coming from the vendor. The vendor will be sending that motor to the individual that can receive it. And hopefully, when we send out these, the timing will work that when we send out the certification rocket, certification motors will be able to do the competition motors as well, especially if you're able to do those 2 launches at the same time. You will, that's for competition. Sorry, I just want to make sure I have everything. All right, when you arrive at the launch site, something to remember that there may be COVID restrictions. There may be limitations on the number of people at the launch site, launch pad, social distancing, mask mandates. You may have to take a temperature check. I know at Wisconsin, we require a COVID release form be signed. So don't be surprised if your local chapter, your local launch site asks you to do the same thing. Next slide. So what are some things that we ask of you? When you go to get your certification, we want you to take a picture of the launch site with you there, with your TRA certified mentor and the RSO, I didn't have the RSO on here, in the picture prior to you launching the rocket, okay? And again, we need to have the information of the launch pad manager in case there's any questions about the certification. Take a picture of your launch site with the rocket and your mentor and the RSO after you recover your rocket. So the key to that is you have to not only launch your rocket, but you have to bring it back so that it is recovered and it's flyable again. So we want to make sure you've been able to do that. Then take a picture of the completed membership application so that you can email that all in to Connie. And part of wanting the pictures as well is because we want to highlight what's happened. And we're not with you this year, so we need your pictures to create the story of what you guys have been able to accomplish in the last 2 days. So fees, there may be fees associated with your certification launch. We are able to reimburse you. So things that we can reimburse you for, we can, we have the membership fee that we're paying for, the certification launch fee. So sometimes when you go to the launch site, there's a fee, maybe a $10 charge to launch your rocket. If there is a fee, we can go ahead and reimburse you for that. Sometimes there's entry fees. So in Wisconsin, we're at a Department of Natural Resources park. And so when we go to enter into that park, they charge a $10 fee. We would reimburse you for that $10 fee. We are paying for the rocket and then the mileage. And I know some of the advisors asked, well, we might have to, drive 5 hours to get to the launch site. So we have the resources. We can reimburse for mileage, for hotel and food. And so we can take care of that for you as long as it is in a written budget and submitted to us. And then we'll approve it and then you'll be able to go. And yes, you can, if necessary, do it separate for the certification launch and the competition launch. But everything has to be approved just so we know what's going on. So another note is the goal is to have all competition or certification launches completed. I think it's by May 31st. And so we also then need all of your reimbursement requests by then as well. So making sure that you get those into WSGC. Next slide.
Are there any questions before that? Because we're going to go into some fun review questions.
Get your thinking hats on.
So you also mentioned that on the planned launch weekend, if it was going to be in Wisconsin, there'll be events. So we should not launch on that weekend, but be available to be Zooming with you guys?
Depending on where you are and what your location is, we are going to try to maintain the extracurricular of some sense for that competition weekend. So on Saturday, we are still planning to have our ending event, which would start approximately, and we haven't finalized this yet, would be 6:30 Central Standard Time, which would be 4:30 in Pacific Central or Standard Time. So if you guys are, depending on where you're at, if you can do your launches in the morning and have them completed, that would be fine, and then come back to the Zoom event because we are hoping to have our guest speakers still attend and give out our awards that evening.
Yeah, I just had to look into what connectivity is like at the launch site or the hotels nearby.
Sure.
Yeah.
Okay. And again, you can, we have until the end of May to try and get all of these launches in. And if you're going to have any need to have it be on May 31st, you need to contact us and let us know and ask again for a request. And that is for, the anomaly, the rare circumstance. We really want to try to have everything submitted to us by May 31st because I did just received word that we are able to give the grand prize winner their $3,000 award, or I think it's 3,000. Is it? I can't remember. Is it 6? I can't remember for this competition. I'd have to look it up. My apologies. but also the VIP tour of Kennedy Space Center. And so we're trying to do a couple of different things. We know that the visitor center is open and we're going to be able to do that. And we also are working on things like maybe lunch or dinner with the astronaut and a few other things that despite COVID we'll still be able to do. So try to get everything in by May 31st. Next slide.
For the travel budget you talked about that's due Monday, that's separate than the competition budget?
Correct. Yep, this is just for your certification. So if you know that you're going to do them at the same time, then you can simply say, we'll submit this with our travel budget that's going to be due with our competition because we're going to do it on the same date. But if you're doing it separate, then we need it as soon as possible on that date. Okay. This is the next.
Sorry, Christine, if we do that second option and send you the budget with the competition, would we get the extra funds, or do we does it eat into the competition budget?
So you guys have $4,000 for your build project. And then typically what Wisconsin Space Grant does is we pay for your hotel. We pay for almost all of your meals. And then for the rocket workshop, we would have paid normally either for us to travel to you or you to travel to us. So we have the funds to be able to support you for both, for the traveling for that. So it does not need to eat into your $4,000.
Great, thank you.
You're welcome.
Okay. There's no questions, no more questions. Party time, review time.
All right, so we're going to do a quick review. Who can tell me what are the two professional rocketry associations?
Tripoli and NAR.
Yes, sir. Good job. What must you do to become level 1 certified? This is critical.
Launch and recover.
You need to launch, so you need to build a rocket by yourself, nobody helping you. You need to launch it and you need to recover it, and it needs to be flyable. Okay. Next, what checkbox is critical to check or uncheck in RockSim?
Mass override.
Good job, D'Angelo. Where can rocket supply equipment files be downloaded from?
Rocket logo.
Vendors.
Rocket Review. Is that what you said? Did I hear that?
Yes.
Perfect. Yep. Where can you find, so I'm not going to do that question because we're not coming to Wisconsin, but logistics otherwise or any other information, we always know that we can go to our website to find that information. Who are the key personnel at the rocket launch? And there's 3 people that we need to focus on.
The one who's going to inspect and certify your rocket, who's impartial.
Who is that?
The certified personnel. I'm not sure how to describe them.
What was that?
Range safety officer.
We need the range safety officer. That's one person. That's one of the key personnel at the rocket launch. Who else?
It's in your handbook.
The level 2 or level 3.
So that's the person that has to be able
person.
to accept your motor, but at the launch site, you have the range safety officer. You have the, look at Frank. We have the launch safety officer. What did I just say? You have the launch safety officer and you have the launch pad officer. Okay, so you have 3 people. So usually Kevin, he will often be our launch pad manager. So he's out by the rails where your rockets are going to be. Often, let's see, range safety officer, I think you do that most of the time, Frank, right? Sky's clear.
Mhm.
Yep. And usually launch pad safety officer, if I'm not mistaken, Bob is that for us. He's checking your rocket and making sure everything's good, and he does the final clearance for counting down to launching your rocket. So those three people are the three people that you need to know and at your launch site. So what is the key enemy of your rocket build?
Was it mass?
It was weight. Yep. So making sure that we want to make sure our rocket doesn't get too heavy, or that it isn't too light, but it is at that perfect weight. Next slide. What does an altimeter do?
Height sensor.
Where the rocket goes.
It can be a sensor.
Depending on the type of altimeter, it can measure different things like altitudes, pressures, depending on the channels it has. But overall, it's also used for their ejection charges to separate the rocket and deploy the parachutes.
Perfect. Yep. So it's going to trigger that ejection charge. All right. And record flight data. What type of knot can you use to attach the shock cord to the bulk plate?
Slip knot.
Slip knot. What can result if you have an improper fin installation?
Shatter?
They could
Good enough for me.
come off, they could shatter, you could have, also you could have instability. So we want to make sure that those fins are on nice and secure, and we don't get fin flutter because they're a little bit loose. So we want to make sure they're in there nice and tight. What is a reasonable rocket descent rate?
Less than 20.
Yep, very good. And describe who can tell me what the CG is, and what does the symbol look like that you need to have on your rocket when you go to launch it?
Center of gravity, and it's the crosshairs.
Crosshairs, yep. And who can describe the rocket CP?
Center of pressure and the way in which you said CP, right?
Yep.
Oh yeah, center of pressure and the way we distribute the mass and the payloads across the rocket body. So more like the structural masses like nose cone and fins and all that kind of thing.
Okay, and then what is the mark that it is going to be on your rocket? Somebody different tell me. Anybody know?
Isn't it concentric circles with the inner circle filled in?
Yep. Good job, Tyson. All right, and so lastly, what is the optimal stability margin?
It was less than 2 and greater than 1.05.
Is it 1.05 or 1.0, guys?
1.05 is an example.
Yeah, so it's between 1 and 2. Okay, next page. Good job. So what were our objectives? We wanted to introduce you to the design, build, fly stages of high power rocketry. And that we remember that this was an introductory. We weren't going to get to all of it, but we wanted to make sure that we covered it in enough detail that when you walk away that you're going to feel more empowered and to be able to build a rocket on your own and to be able to compete with a lot more confidence. So you were able to build a level 1 high powered rocket. So we built the Lock Precision ISE kit. And then to give you a basic understanding of RockSim and what that flight simulation is going to look like and the power of that program for you as you build your rocket and plan for your launch. And then also to understand the Tripoli Level 1 certification. So hopefully you walked away with feeling like you guys pretty close to mastered those four objectives. Next. So in the end, we want to know how we did over the weekend. And, you know, I always say, try to give 80-20. We love to hear the good, right? So what was the good we were able to accomplish over the weekend? And then if you have some things that we could actually do better, go ahead and tell us what that is too, because then we're going to be better for the next group that comes behind you. I want to thank all of you for your attention, for sticking with us all the way to the end. We hope that you are as excited as we are. So before anybody gets off, what I want, Willie, can you come on back? We want to get a screen grab of everybody holding up their finished rocket so that we can, that's what we want to display. Usually, as you saw in the one picture, everybody's kind of, you know, holding it up and it's our end. And we can't necessarily do that virtually, but we can definitely do this. So let me get my screen ready. My snipping tool that I want. Oops, hold on. Let's do that again. Hold on. I don't know. Shoot, I lost it. You guys are holding on, right? All right. Does everybody? Oh, I love it, Nikki. You're excited. Look at you, James, Andrea. Can we see more of it, Andrea? All right.
It's not together.
That's okay. I'm trying to see, do I have everybody in this? Am I missing anybody? No. Okay. All right. So on that note, on a count of three, and then I need you to hold until I make sure our picture has been snipped. Okay. All right. 1, 2, everybody's smiling, and 3. Hold. All right. Good job, guys. Thank you so much. That's going to be awesome and great. Greatly appreciate it.
All right, please don't leave until you complete the survey. It's in the chat, but once you finish that survey, you can feel free to enjoy the rest of your weekend.
And you guys should be happy. We're 20 minutes early.
Yeah.
Andrea, I was watching the video. Looks like you got it all together.
Yeah, I was able to tie everything without using the little hook or what do you call them? Switch?
Quick link?
Quick links, yeah.
Perfect. Good job getting that out.
And we're going to stay on just for a few more minutes. So if you do have any questions, you can feel free to ask us. But if you don't, and you're done with that survey, once you finish it, feel free to have a good rest of the day.
Thanks. Now I got to go shovel.
I have to prepare to shovel.
Oh, light out there.
I think we can go ahead and stop recording, Danielle.